All right, so now that logging is in here, we're going to say running, and we want to know the name of the process. And we want to know how Python ran this. So I want to say name. Remember, if it's underscore underscore main underscore underscore, then that means Python's running the script correctly. Otherwise, it will be named something else. So I want to know how we're actually being run as. And then I'm going to say finished. Don't really need to know the name for that. And then we're just going to simulate some type of work here. So I'm going to say time.sleep. And I'm going to take whatever number they give us and factor that by 2. Why not? You can feel free to change that to whatever you want, however long you want to wait. I don't want to waste a lot of our time here in video land, so I'm just going to say 2. And that's it. It's really that challenging. It's just a normal Python function, and we can run whatever code we want to run. So let's look at how we actually start the process. Let's take a look at basic process usage, and this is not at all hard. I was a little intimidated the first time I did this years and years ago, but Python makes it simple. I mean, ridiculously simple. In other languages, this puts fear into senior developers, but Python, you can do this in minutes. So we're going to say main. Now, unfortunately, with that simplicity comes a degree of complexity as well, which we're about to talk about. So in our main function here, normally what we would do is some sort of configuration. So for example, I'm just going to take this code, plop it in. You see logging, and if I go ahead and run this, nothing's logged. Well, simple. We just have to configure the logger. So I'm going to paste that code in there. We've done all this logging configuration before, so I'm not going to really explain it. Watch my previous videos. But now everything will work. We're now actually logging. Notice the name, underscore underscore main. Some boxes and some versions of Python are different. So for example, as we run this on this Linux machine, every process is going to have a name of underscore underscore main, but Python's using the process name to determine if it's the main process or a subprocess. On my MacBook, which is literally sitting 1.5 feet from me, has a different OS, different version of Python. It acts totally differently. And what I mean by that is as we run processes, it will start here at this function, which effectively never runs this main function. So logging never gets configured. So we never see the logs for our processes. Oh, that is frustrating. So to negate that whole problem, what I like to do is not configure logging in main, but instead I'll configure it out on the global scope. That way, all of the subprocesses, regardless of Python version, are going to have the same logging level and configuration, and everything's going to just magically work in the background. So, all right, we ran that. We got no bugs. Let's go ahead and clear this out. And now let's actually work with processes. And this, I always try to make this harder than it needs to be. So forgive me if I start slipping up. So I'm going to say processes, and we're just going to make a list of processes for X in range. Let's just say we want 5 processes. Now we're going to say P equal multiprocessing dot process. We want the class, so make sure that's an uppercase P. And then the API is exactly like threading, which is why people get very confused. Say target, and we want our run function, args. I always love that word, args. We're going to say X, so I'm going to give it a list of arguments here. Now we want to set this to daemon equal true, meaning every time we start a process, we want to make sure not only is that process running, but if we kill our main process, we want all processes we've started to also stop with it. We don't want a lot of hung processes sitting there chewing up memory. So we want to say processes.append. And we're just going to append that process, and then p.start. We're going to start each process up. So we're going to have to wait for those processes, but just look at this code right here. We're just saying start a bunch of processes, and then our program is actually finished, or I should say our main process is finished. So watch what happens here. You can see running main, and then we have process-1, finish process-1, starting process 2, but our main process finished. We never saw finish 2, and process 3 is kicked up, but we never see finish 3, meaning we killed all those processes, while they're in mid running. That could have corrupted data, could have done some very bad things. So we are going to wait for the processes. And this sounds super complex, but it's really this simple. For p in processes, join. And it's going to do exactly what you think it's going to do. It's going to sit there and block execution of our main process until all of these other processes are done. It's going to join it back into the main process of execution, if you will. So let's go ahead and clear this out and rerun. Now we can see we are spawning up all these other processes, and then we're just going to wait for them to finish. Every single one of them is the number times 2. So by the time we get to 5, we have waited 10 whole seconds. This is extremely powerful. I mean, I cannot even begin, especially if you're a complete newbie and you're just brand new to multi-threading and even multi-processing. This is why Python is used in data science and artificial intelligence and deepfakes and all that other high-end technology, because you can really utilize the full power of the machine very quickly without knowing a lot about computer science. So just to recap here, multiprocessing is using the same script across multiple processes. There is a slight little, I don't even want to call it a bug, but maybe version issue where if you configure logging in your main, you may not see it in your child processes. So you're going to want to do that out on the global. And you may notice you should not depend on this name, this process name. Don't like try to hard code that or anything, because it is determined by the operating system and even the version of Python itself. And when in doubt, always set your processes to daemon equal true. That way, if your main process dies or you shut it off or the user kills it, all your subprocesses stop with it. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. My name is Brian, and we're going to continue our journey into Python with multi-processes. We're going to look at starting and stopping. In short, we're looking at the full process life cycle. Here's an example of what we're going to be doing. We're going to start the application. We're going to start a worker, and then we're going to finish and get the end result back from that worker process. When I say end result, we're talking about the exit code from that process. Let's take a look. First things first, before we can do any work, we have to do our import. So we're going to import logging. We're also going to import multiprocessing. And then we're going to say from multiprocessing dot context. Now, when we talk about context, we're talking about the context of execution. Specifically, we're talking about a process. So when you think about context of execution, really you're talking about scope. Every process has its own scope. It's actually pretty cool how that works. So we're going to go ahead and import time so that we can stop time when we need to make it look like the program's actually doing a lot of number crunching. We are going to do more complex examples in the future, but we just want to simulate work at this point. So let's go ahead and define the function that our worker processes are going to use. And in this example, we're only going to use one process, but it can be used over and over again for a number of processes. So I'm going to say def, let's go ahead and call this work, and let's say MSG for message and max. So really, we're just going to count something out and spit out a message. So let's go ahead and get the name of this. I'm going to say multiprocessing, current process, and we want the name. From there, I'm going to say logging.info, and yes, assume at this point that logging is actually configured correctly and everything's just expected to work. We're going to cover it in a later section here, but just for grins and giggles, let's just assume that it's already set up. We're going to say started. And then I'm going to say for x in range. And this is where we're going to just simulate some work here. We want it to go up to the max. And let's go ahead and say logging.info. And let's just print out the name and the message here. Now we need to simulate like we're doing some sort of real heavy number crunching or just something. So I'm going to say, let's go ahead and sleep for 1 second. Clearly, this is not going to win any Nobel Prizes for complexity or anything like that. But basically, all we're doing here is we're jumping in. We're saying, hey, get the name and then print out some information on the screen and then go to sleep every second and continue printing out over and over again. Just going to simulate some work. Now that we've defined the function that our worker process is going to use, let's go ahead and work with our main process. Now notice I called this the main process, not the main function, even though it's identical. So the main function runs in the main process. Let's say main, and let's call the main function, which we have yet to build. Now before we do any of that, we are going to set up logging. We want to make sure that all this stuff works across multiple processes. Remember, the way Python interprets this is it's going to go in and it's going to configure logging based on the config, but it's only going to do it one time. And some of the different versions may do this a little differently. So I put the logging config before I've even called main. So we're just going to make sure that's called no matter what. Now, realistically, it should be configured here, but on older versions of Python, that's just has been no luck for me. So we're just going to play it safe because I don't know what version you're going to be running. All right, once we're here, we can go ahead and say logging.info, and let's just simply say started. Now we want to actually pick up a worker process. So let's go ahead and call this worker equal, and I want to create an instance of the process class. We're going to say target, and this is going to be our work function. We want to give it some arguments. Say args equal, got to hand it a list. And let's just say working, and then we need to give it a number here. So let's just take a step back. I'm going to make a variable called max, and we're going to put it right here. Max equals 2. And this is going to be critically important to this little demo application. So really all we're doing here is we're calling this process with this function with these parameters here. Now max is going to do this range, and that's going to be the number of seconds we're going to go to sleep. So this right here would say sleep for 2 seconds. That's going to be critical by the way this is going to function. Almost done. We're going to say we want to be a daemon, and let's go ahead and set this to true. Now, we didn't do this in the last video. Let me move my mouse so you can see, but we're going to actually set the name of this process. That's right, you can actually name them. Let's call this worker. You can name it whatever you want, doesn't really matter, it's just a string. We can go ahead and start our worker. Maybe if I can actually spell it. There we go. From here, what we're going to do is say time.sleep. And this is our main process. We're putting this to sleep. And we don't do this very often, if at all, in the real world because you don't want to hang your program up. But we're going to say main process, go to sleep for 5 seconds. There's a better way of doing this, which we're going to cover in the next video. But for now, that's what we're going to do. Now we're going to say if the process is running, stop it. This is a bit dangerous with processes, so you gotta be a little careful. So we're gonna say if worker dot is alive, and this is gonna be a bool. We're going to say worker dot terminate, and then we want to say worker dot join, and we're just going to join that back into the main process execution. Seems a little confusing here. So really what we're doing here is we're saying make a worker, put it to sleep for 2 seconds. We are going to go to sleep for 5 seconds. When we wake back up, if that worker is still running, still alive and kicking in memory, we're going to terminate it. And that's a very dangerous thing. it's going to send what's called a SIG term, or a signal for termination, which is going to tell that process, we are shutting you down and there's absolutely nothing you can do about that. Now think about that. Have you ever been like typing a note or an email or something and then the program crashes and you lose all your work? That's exactly what we're doing to that process. That is pretty dangerous. So we want to be a little careful on when, how, and why we do that. So from there, we're going to say worker, let's go ahead and join all that back into this main process, and then we're good to go. And then let's just simply say logging.info. I want to format that out. I'm going to say finished. And we want to get the result or the exit code back from that worker. Now, this is different than returning a value. This is the actual process exit code. And what we mean by this is if an exit code is 0, and I'm going to actually put this here, 0, maybe, there we go. Exit code equals 0 is good. If the exit code is not 0, it's very bad. And those exit codes could be operating system specific. They could be something that you as the developer would actually determine. But basically anything other than a 0 for an exit code means something bad happened. All right, let's go ahead and let's get some screen real estate here. And assuming I didn't mistype anything. All right, started, worker working, and then finished, exit code of 0. So it did work as expected. Now, it worked because of our timing. We're saying create a process, go for 2 seconds, sleep for 5. So we have 3 extra seconds. That's why there was that little delay down here. Let's see that in action again. You'll see started, working, 1,000, 2, 1,000, and should finish right about now. There it goes. That's why that works. Now, watch what happens if I set this to 6. Actually, let's just play it safe and set it to 10. So we're going to say start a process and run 10 times, but the main thread is only going to sleep for 5 seconds. When we wake up, we're going to say if that worker is alive, terminate that worker. We're going to send that SIG term, that very bad thing, and we're going to tell it to shut down. And you're going to see we are not going to have a 0 for an exit code. It will be probably a 15 would be my guess. See this in action. So after 5, it should wake up and then, yep, finished, -15. So that is the SIG term, or the termination signal that we have sent to the process. So what happened in memory, this process was happily churning along and doing its thing, and then it died a slow, horrible death, or actually a very quick death. Let's go ahead and say logging.info. And let's go ahead and say, actually, I'm just going to copy this whole thing. Just for a little bit of clarity there, we want to see when this process starts and when this process finishes. And we're going to rerun these examples. So let's go ahead and set this back to 2. Clear this out. So you can see our worker finished, and then after a few seconds delay, our main process finished with the exit code 0. So basically that's what join is doing, is it's saying, hey, merge all that memory back together in the background, make sure we know what we're doing. Python gets all the information it needs, and we can grab that exit code. Now, this is the fun bit. Let's go ahead and set this to 20. Doesn't really matter. As long as it's longer than our 5, it's really not going to matter. Let's go ahead, run, and let's see this in action. Uh-oh, you notice the problem? Worker working. The worker never finished appropriately. That's why we have this -15, which indicates the exit code is greater or less than 0, or I should say not equal to 0. That means something very bad happened. So as this process was running, it could have been on this line, it could have been on this line, it doesn't matter. The operating system came in and killed it, and we lost whatever we were working on. So if we were building like a file or a socket connection or something like that, it just completely got obliterated. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to talk about the multi-process pool, and this solves the problem we had in the last video, where we want to create a worker, have it do some work, get the result back, and also wait for it to complete. So we're talking about pools of processes and getting their results. The end result is going to look something like this, where we're going to start our main process, and then we're going to have some worker processes, and we're going to be able to see when they finish, and we want to actually get the result of each one of those back. When all of our processes finishes, we want to automatically finish our main process. Let's dive in and take a look. First step in any application, as you guessed it, is our imports, and I'm going to just do a little bit of copy and pasting. We're going to use logging, multiprocessing, and then from the multiprocessing context, we want to use process. We're going to stop time, and we're going to use a random number generator. This example is going to be eerily similar from the last example. So if you watch the last video, it's going to look virtually identical, but we're going to do this very, very differently under the hood, and we're going to have much better results. Let's take a look. All right, now that we've got our imports, we can go ahead with our worker process function. And this is going to be virtually identical to the last video. I want to show you that you can do basically the same thing. It all happens under the hood the way you would expect it, so there's really no gotchas. Just in case you really missed the last video, I am going to actually type this out. Don't want to waste your time, so you can feel free to skip ahead if you watched the last video. But so I'm going to say define work, item, count. So we're just going to have an item or some sort of name or message, and then we're going to have the number of times that we're going to count, and on each iteration of that count, we're going to go to sleep. So I'm going to say name, and I want to do multiprocessing dot current process. I'm going to go ahead and get the name of this, maybe, if I can actually type it out. Yeah, my keyboard is just not being super helpful today. And then we're going to do logging, and again, we're just going to assume that by the time it hits this point in the process that it's actually, logging's configured and everything's good to go. We're going to just format that out, and I'm going to say we want the name along with started, and I want to know what we actually started here. So I'm going to give it the item, which is this parameter right here. So we're going to say the process name started whatever item we're starting. That way we can start having different blocks of work that we can segment off to different processes here. I'm going to, just for the sake of time, copy that so I have it. And then for x in range. And we're going to do it for the count. Again, very, very similar to the last video. We're going to say logging info name, and then I want item equals x. It really doesn't matter what we put out on the screen, just as long as we can show, hey, we are doing something, the process isn't hung up. And then we're going to go ahead and say, let's go ahead and put this process to sleep, or specifically this thread in this process to sleep. If we had other threads running in that process, they would be happily churning away in the background. And then we're going to go ahead and say logging info, name followed by finished. Now we're going to do something a little bit different here than the last video. I want to actually return a value, and this is why I wanted to type all this out. So return, remember the last video didn't return anything, but this one's going to. So we're going to say item plus, and then just a string, I don't really care what we put, is finished. And you could put some sort of number or whatever you wanted to return here. It could be an int, a bool, string, tuple, doesn't really matter. You can just return whatever you want. So looking at this, it's Well, it's boring. It's plain Python, but that's the point. This is so powerful. You can give it very simple code and even very complex code, and it's just going to work on a multi-process system. Okay, major takeaway from the last section, just in case you did skip ahead, is our function is almost identical except for we are returning a value. It doesn't really matter what we return, we're just returning some type of value because we're going to get that return value back. We're going to do that in the main process. So I'm going to just say main, and let's go ahead and define our main function. Got a little keyboard happy there. Now I'm going to go up here and I'm going to define what's going to be called a callback. If you're not familiar with a callback, it's a process or a thread or even another function is going to call back or basically call our function. And we don't know when that's going to happen. So we're going to say proc result. And I'll explain this a little bit here in just a second, but right now just kind of take it on a leap of faith that something is going to call this. And we're going to say result. From here, we're just going to say logging.info. Let's go ahead and format that out. And I want the result equals, and then whatever the actual result is. Now, in case you're wondering, what is this result going to be? Well, it's actually going to be the returned value here from our worker process. That's the beautiful part about what I'm about to explain is you can actually get the return from your worker process, assuming it actually had an exit code of 0 and it worked as expected. You can get that. If it was terminated, it's never going to call this proc return. At least I don't think it will. I haven't fully tested that, but I don't think it would. I may actually test that in a future video. Anyways, moving along, we're going to go ahead and do our logging basic config, and we're going to flesh out this main function. I'm going to do just a smidge of copy and paste here. So I'm going to say started, max equals 5. So we now need to grab a pool because we're talking about pools of processes. We've talked about thread pools before, and it's virtually the same thing. It's just a group of reusable processes. So I'm going to say pool equal multiprocessing.pool. And that's with a capital P, max. And that's going to create an instance of that pool object for us. I'm going to say results equals list, because we're going to get a list back of these results. Now, when we talk about the results, this is actually different than the process result. We're going to be working with asynchronous future values. We're going to say for x in range, max, and I want to make an item here. This is just going to be an argument we're going to pass to that. So I'm going to say item plus the string representation of x. Our count is going to be, and yes, you may have already picked up what we're doing here is we're making this stuff right here. So we're just going to make the values for our parameters. So we're going to say count equals, and here I'm just going to do a random. Say random dot rand range, and we want to do, say, from 1 to 5. You can put whatever number you want, but I'm trying to keep this video a little bit short. Notice right off the bat, we don't know how long this process is going to run for, because each count is going to make this go to sleep for 1 second. So we're going to have to figure that out, and that's what we're really working with these results with. So I'm going to say R equals, and we want to take our pool object, and I'm going to apply. Now you notice there's an async. Apply is going to do this synchronously, meaning it's going to do it one at a time, where apply async will do it all at once. Whenever you see asynchronous, immediately think of everything all at once. Now, spoiler alert, there is also a map and map async, and that will take a function call and map it to an iterable list or an iterable container of some kind. that gets a little murky when you have to fill in all these values and stuff. And that's why we're doing the apply async. It's a little cleaner looking on the screen, basically. They both accomplish the same thing, though. And then I want the item and the count. Now that we've got that in there, what we need is the callback. In case you're wondering, I could actually be really nice about it. Add the target, add the args. That way it's a little clearer about what's actually going on there. And now we want our callback, which is our proc result. This guy right here. So basically what we're saying is pool, apply asynchronously, meaning go out and do this all at once. I want to do 5 of these. All of them should start with that function, work. Here are the arguments we're going to pass to that function. And if you have a result, I want you to call back to this function here, proc result, which is this guy. Now, if we were to terminate this process that's running, we're probably not going to get a proc result. And if we did, I wouldn't actually trust it anyways, because it would probably be some sort of corrupt data. Now I'm going to say results.append. We're going to add that asynchronous result in there. All right, so a little bit confusing about what's going on, but now we have all these processes running. We need to wait for the results. So I'm going to say for our in results, and there is better ways of doing this. We're still in newbie land, so I'm taking kind of the easy path here, and we're just going to wait. And yes, you may have guessed this is a little bit dangerous, and you should put some sort of optional timeout in there. We're not going to do it for this specific video, but you can put a timeout in there if you don't want to sit there and wait for a process forever, because you could very easily hang up your program if one of those processes just doesn't play nice. All right. Once we've gotten all those asynchronous responses back, we're going to say pool.close. And notice how I have this in a comment, because you can do that, or pool.terminate. Now, close is a very gentle way of doing it, where you're just simply closing the door, and terminate is like slamming the door in somebody's face. And you don't want to do that, because it will send that sig term out to those processes and just obliterate them. So I'm going to say pool.close. We're going to do it the friendly way. And now we want to take all of that great stuff, all that machinery in the background that's running, and say, go ahead and join all that back to our main process. And then from there, I'm going to say logging.info. And I want to know that our main process is now finished. Whew. All right, a lot going on there, but let's take a look at this real quick before I run it. Assuming I didn't have any typos, we have our main function, which is going to go in. We're going to get a multiprocessing pool, which is a pool of processes we can use. We're going to get a list of results, and then we're going to say for x in whatever maximum we put, in this case 5. Go ahead and let's make our parameters here, or actually our arguments. So we're going to have a string, and then we're going to have some sort of integer of a random number. And then we're going to go ahead and say pool, go ahead and apply async, which means it's going to go out to our pool and say, create all of these at once. Don't wait on us, just go do your thing. And as soon as those are created, those are going to start working even as the pool's creating processes. It's actually really cool. Then we're going to have a target of this work function up here. We're going to pass those parameters. And then we're going to have a callback. So we're going to say, hey, process, if you've done your work, you haven't crashed, and I haven't terminated you, go ahead, return your value, and return it to this function here. And then we're going to spit out the result. From there, we're not done. We're going to wait on those processes. So we're going to say for each asynchronous result, we're going to wait, which basically puts our main process in kind of a holding pattern until each result is done. We're going to try to gracefully close that pool, and then we're going to join it back into the main process. And finally, the glorious moment where we are finished. Let's go ahead and fingers crossed that I actually typed all of that out. And I did not. We have been betrayed. Okay, so where are we at here? Line 50. Let's go down to line 50 here. No, the wrong one. Line 34. All right, what do we got here? Apply async got an unexpected keyword argument of target. Oh, yeah, I put those in there for example, and we don't need them. That's why. There we go. So we're going to do positional work and then our variables. Now it should work just as expected. There we go. So you can see we have started up and now we have finished. So we have gotten items are starting, and you can see they're already working as the pool is starting other processes. Then they're going to churn away and work in the background. We can actually see the individual workers finish. And then at the very end, we get all of our results back. Once all the results are in, we are now terminating our main process. Let's go ahead and kick this out just a little bit. I want to do a longer version, so I'm going to say 10 seconds. Quick look at our code. Unlike the last example, we don't have a hard timeout. We are going to wait on all of these processes to finish. So I can kick this out as long as I need to. Although you could and probably should put some sort of timeout right here. So you could say there and it will raise some issues. But for this example, we're just going to wait indefinitely until these are done. And let's see it in action. So this is the multi-process pool running 5 worker processes for 10 seconds. And there we go. Working as expected. Major takeaway from this is highly simple and highly efficient, and you can get a callback, meaning you can get the end result back from those processes. One thing to take into consideration is waiting for a process could have bad results, and you may have to work out how to actually wait for it and how you want your program to behave. And then when you're done, you have to decide, do you want to gracefully shut the door or say, you know what, I'm done waiting on you and I'm going to just slam the door right in your face, and that will terminate the processes. And then we're going to join everything back into the main process. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're talking about asynchronous code in this video. So what is asynchronous code? I'm sure you've heard this buzzword and everybody is throwing it around like it is just some magical thing. Really, async code runs in the same thread. What? Yeah, that's right. It runs in the same thread. It appears to be some voodoo magic where the code looks like it's running in a multi-threaded fashion, but it's all on the same thread. So what async does is it uses a coroutine to run on the same thread. So in the background, it's really scheduling this stuff. We're going to introduce some keywords, for example, async and await to really describe this. But what we're talking about, let's say we had a few things like thing 1, thing 2, and thing 3. And we wanted to run all of those at the same time. Well, multi-threading comes to mind, but then when you have threads, you have all this complexity like locking and crashes and joining and all this fun stuff that just really sucks. So what async does is it takes the same thread and it says, you're not usually using the entire thread. For example, something like this. How much of that thread are we actually using here? Well, we're using the entire thread. But how much work are we actually doing? Very little, actually none, because we're doing pass. So what asynchronous will do is say, okay, if there's any unused time, because remember a thread is a slice of time on that CPU, go ahead and get that extra time and do something else. So, for example, we could run this, and this, and this, and this, and we could just keep going. And it would all appear to be running at the same time. And really all it's doing is it's using the unused time on the same thread. Let's dive in and take a look. Okay, the first step in any application, you guessed it, is the imports. So I'm going to get a little copy and paste action off the side here. We're going to use threading, multiprocessing, log. Now, wait a minute. We're talking about async. Why are we using threading and multiprocessing? Because I want to be able to display to you the thread and the process that we're running in. And you're going to see that even though it appears like it's a multi-threaded application, it's all on the same thread in the same process. And to display that, we're going to use logging. Now, from here, we're going to add something new to our arsenal. I'm going to say import, and we want async IO, which stands for asynchronous input output, async IO. We're also going to use random, our good old buddy, the random generator. And just for giggles, because I know you love it, you just cannot get enough of it, we are going to use logging. So we're going to say logging basic config, and we're going to configure this right here at the top so there's no mystery as to where it's getting configured. I got some really good user feedback where they said, sir, we don't understand how you're configuring logging. Can you explain it? So to overly simplify it, it's just right here at the very top. Okay, let's go ahead and make our functions. And this is going to be the bulk of the video, so I'm going to slow way down here. I'm going to say def, and let's make a display function. And the whole point of this is to, well, display the log. But I want to do this in a special manner. What I want to do is say thread name, and you guessed what we're about to do here. We're going to say threading dot current thread, and we want to get the name. And then we're going to get the process name. And it's probably pretty obvious what I'm about to do here. Multiprocessing dot current process dot name. I just want to shove those in some variables so we don't have some big long line of code that we're looking at. But you could very much condense that down into a one-liner if you wanted to. Then we're just going to say logging.info. We've covered logging to the point it's almost ridiculous to even talk about it. But basically, at this point, all we're going to do is shove this out into the log. And we want to say the process name slash, we could put this really in any format we wanted, thread name, and then whatever the actual message was. Probably help if I put that correctly. There we go. Very, very simple display function. Now, from here, we're going to make an asynchronous function. It's very complex. I want you to pay attention. We're going to say async, and then whatever our function is. It's really that simple. I lied to you. It's not hard at all. From here, it just looks like normal Python. But it's pretty important to note that this async keyword defines that we are going to have the ability to run this function asynchronously. Doesn't mean we have to. It means we have the ability to. We're telling Python, modify this code when you do your magic under the hood so that we can run this asynchronously. All right, from here, we're going to say display. And I want to go ahead and display the name plus, say, starting. I can actually spell the word. There we go. Keyboard has betrayed me. And because we've started, I want to know when we've finished. And then we're going to, well, do something. And I don't really care what we do. We're in newbie land here, so we're just going to simulate some work. Now, we're going to introduce yet another keyword. When we're talking about asynchronous functions, remember, these will appear to run at the same time. They're going to use that dead space in the thread timing on the CPU. So anything that we're not currently chewing up on that CPU, it's going to shove that in there and try to run it. We want to be able to synchronize asynchronous code. And to do that, we're going to use the await keyword. And this does very much what it looks like. It will wait for a asynchronous function to complete. For example, we're going to say async IO dot sleep. And that does exactly what you think it would. It's a coroutine that completes after a given number of seconds, which basically means it's an asynchronous. When you see coroutine, it's an asynchronous sleep function that goes after a couple seconds. So if you don't do the await, you're either going to get an error or it's just going to immediately jump to the next line because guess what? This is now an asynchronous call. All right, so let's go ahead and jump in here and I'm going to say random dot. Let's do rand int. I've been doing rand range, but I want to like mix it up a little bit here. I'm going to do 1 to 10. And really, that's it. That's our worker function here. So this is an asynchronous function. Now, a little bit of trickery here. It's an asynchronous function calling an asynchronous function. And you have to use the await keyword when you do this. Otherwise, you're going to have a bad time in async land because it's just going to plow forward and not even pay attention to you. So let's go ahead and make another function here. I'm going to say async. That's your big indicator that this is going to be asynchronous code. We're going to define run async. And I want a maximum that we can work with here. Go ahead and make a list of tasks. And then 4x in range to our max. Let's say name equals, and we want to just make some sort of string representation here so we can see what the heck is actually going on. And then we're going to say tasks.append. So really we're just going to add to our list and we're going to create some type of task. And we're going to make an async IO dot ensure future. You want to make sure you have a future in life. So that's why you're learning programming. But really what this thing does is it wraps a coroutine or an asynchronous function into an awaitable future. There's your keyword, awaitable, meaning you can use the await keyword when calling this. Really, a lot of fancy jargon, but that's really what's going on there. So let's go ahead and make our coroutine. We're going to say work name. This is a little bit different than what we're used to. We're actually giving it the function with the parameter. Under the hood, what's happening here is Python's going to wrap that whole coroutine into a future and allow us to await for completion. Seems pretty challenging, but it's super simple when you look at it. Now we're going to go ahead and say await, because we want to await for all of them to get done. Async IO dot gather. And what gather does is it, just imagine asynchronous tasks are like a bag of marbles, and you drop that bag of marbles on the floor and they go everywhere in all different directions. So now you want to gather them all up, and you're going to wait until you've got them gathered up. That's kind of the visual you'll get there. But really what we're saying is wait on this asynchronous call, which is called gather, which is going to go through all of these tasks and make sure the future has finished. Okay, no more screwing around. Let's do our main function here. Let's actually see this thing work here. I'm going to say main, got a little main happy there. And in here, we're going to go ahead and display that the main started. Now, because the main started, I want to show the main finished. That way we can see this thing in its life cycle. Let's go ahead and run this real quick. You can see main process, main thread, main started, main finished. So now we have the process, the thread, and then whatever we got there. In here, this is where we're going to make this asynchronous magic really, really happen. The first thing we want to do is get an event loop. So I'm going to say loop equals async IO dot get event loop. And if you don't know what an event loop is, they're happening all the time. As you're sitting there looking at the program on your computer, whether it's a desktop, laptop, mobile device, doesn't matter, there is a loop in the background, which very much looks like this. While true, and instead of pass, it's got some special code that basically says, let other things have the context of execution. So we're going to get that special loop that's in the background, And we're going to be able to manipulate that. So now that we've got our loop, it's actually very, very simple. We're going to run something until it's completed. So I'm going to say loop dot run. And you notice we got some options here. Run forever, run an executor, and run until complete. Now, I'm not going to really cover run an executor because it's a little bit more advanced. Run forever, though, this will make your application literally run forever. This will never stop. No, it doesn't mean it's going to keep going if your computer's off. It just means it's going to go until you forcibly stop the application. So I'm just going to put a little note there, will run forever. But what is that really used for? Typically, you'll see that in long-running applications like TCP servers or things of that nature, or database programs, or something that's going to wait and wait and wait. And they call it the main event loop, where you're waiting on keyboard input or something like that. We are going to do the opposite. We are going to loop only as long as we need to. So we're going to go out here and we're going to say loop dot run until complete. Now you notice the first thing it wants is some sort of future generator. Now, future, that sounds familiar. That's right. We did that up here in this async gather. So it's very simple at this point. We can just call our function run async 50. So what's going to happen when we run this? Well, it's going to go into our run async with a maximum of 50. It's going to say for x in range, which is 50 in this case. And then it's going to just print that out and make sure that it runs. This is really the tricky part right here. We're saying await asyncio.gather, and gather is going to gather all of those tasks that we shoot out into the processor and collect them in a nice fashion for us to use. Now, before we really stop talking and start running this thing, we want to do one more thing. We want to actually close the loop. Closing the loop will free up resources, and it stops the loop from being able to run infinitely and things like that. And it just says to Python and the computer that we are now done with that, and we don't want to use it anymore. We're just going to close it out. Think of it a lot like a file. We're now shutting that, and we don't want to use it anymore. All right, let's go ahead and clear this, and let's see this thing in action. All right, so you see a bunch of gibberish here, but you should notice right before I even scroll up what's going on here. Main process, main thread. Every single one of these, main process, main thread. And I'm going to scroll up. And the other major takeaway here is you see starting. Starts at 0, and then there's sequential, because we're starting these in a specific order. But once we hit finish, you know it goes from item 1 to item 4. This is where it really looks like it is multi-threaded. There's no guarantee in which order this is going to run. The computer's going to decide which order to put it in. This is extremely cool. So let's go ahead and clear this, and I want to run this again just so you can see what's going on. They all start, and then the async IO operations start finishing. This is incredibly cool. All right, major takeaway from this. Asynchronous operations run in the same process, same thread, although it takes out all the complexity of multi-threaded applications. You do have to keep in mind a few different things. For example, you need the async keyword, which marks a function for asynchronous operations. You need the await keyword, which will actually stop execution and say, I'm going to await or wait on the asynchronous function. And we're talking about loops. This is the application sitting there churning away in the background and waiting for something to complete. And when we're done with that loop, we need to close it. And be very careful. If you ever use run forever, it will make your program look like it's locking up, but really it's just running an event loop in the background. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and in this video, we're going to talk about a simple producer and consumer. This is going to demonstrate the queue a little bit better. I had some user feedback, and they said, hey, I loved your video on locking threads, but you kind of said you don't like working with the queue. Can you go into it a little bit more? I don't really like working with the queue, but why not? Let's just do it. So that's what this video is really going to cover. We're going to make what's called a producer and consumer, and it is exactly what it sounds like if this is a new concept. A producer will produce some sort of work, and the consumer will take that work and do something with it. But we're going to put the producer on one thread and the consumer on another thread. Let's take a look. To start off with, we need our imports, and I am going to save a whole lot of typing, and we are just going to do copy and paste. I love copy and paste. Anyways, so we're going to use the random number generator threading and multi-threading because we're going to be threading these, and I want to show you which thread and which process they're in. We're going to use logging. Of course, we're configuring the logging before we do anything else. From threading, we're going to import the thread class, and from queue, we're going to import the queue class, and we are going to stop time. We are not working with asynchronous. This is true threading. I need a basic function, something that's going to be usable by all the threads here. So I'm just going to say def display, and we're going to just blatantly rip off the function we wrote in the last video. And if you skip that one, I'm going to type it out really quick here. We're going to get the thread name from the current thread. So I'm going to say threading dot, and I want the current thread dot maybe name. There we go. Keyboard has betrayed me. And I want the process name from, you guessed it, the multi-threading dot current process name. And from here, it's very, very simple. I'm going to say logging, and we've already configured logging by the time we hit this function, so we don't have to worry about any of that. But basically, anything above debug, which means, well, everything, we want to capture that. So I'm going to say logging.info. Go ahead and format this. And I want to know the process name. We're running this all on one process, so it's kind of redundant. But I want to really know that thread name, and I want the actual message that we're printing out here. That way our logs look nice and beautiful. Now, because we're making a producer and consumer, the first thing we're going to do is make the producer. We need to actually produce the work. So I'm going to say def, and we're going to create work. I want a queue. I want another queue, and we're going to call it finished. And I want some sort of maximum number that we're going to get to here. Now, we haven't actually created these yet, and I didn't want to create global variables, but queue and finished are both going to be this queue class right here. Now, queue is, and somebody correct me if I'm wrong, as you often will, it is a thread-safe way of getting and setting variables. So I'm going to say finished dot put. So we're going to put that out to the finished queue, and we're going to say we are not finished because this producer thread has just started. This function will be the entry point for the producer thread that we're going to be creating later. And then it's very simple. We're going to say for x in range max. So whatever maximum we give it. Now I want some sort of value. This is where our buddy, not the range, the random number generator, is going to do a rand int. And we want something between 1 and 100. Doesn't really matter what we do there. We just want some sort of value. And now we're going to take our other queue. I'm going to say queue dot put. I want to put that value out there. Let's go ahead and display something. So I'm going to say display. I want producing We're going to just say producing whatever iteration we're on and the value that we have here. Now, once we're done with this, we want to shut the producer down, and we're going to do that by simply exiting out of this function. So we'll say display finished. Now, we want to go back to our little buddy, the finished queue. This is a queue just like this one, but we're going to use it in a different fashion. So I'm going to say finished, and we're going to say true. So rather than storing a bool in a global variable and locking and unlocking and acquiring and releasing and all this other fun stuff, we're going to use the queue to just simply put that out there. Now that we have a producer who's going to take our queue and put some sort of value out there, we want to grab that value in a different thread. And this is going to be called the consumer. And this is going to actually perform the work. I want to say work, and we're going to use another variable called finish, which is going to be that finish queue. I tried to keep the names very similar. Notice how I'm not putting a counter out in a global variable, because then we've got to use the global keyword, and then we've got to do all this locking and unlocking. While true, if not work dot empty. In case you're wondering what work is a queue. It's this little guy right here. I could have actually named it queue, but I wanted to name it work just to show you naming convention really does not matter. We're going to say v equal work.get. And under the hood, what happens here is our queue is going to say get the next item in the queue, because you could store multiple items, as we're going to see as we slow this thing way down here. All right, now that we got that, let's go ahead and say display f, and let's say consuming we want whatever our counter is, and then whatever value we got out of the queue. Now I want to increment our counter. Because this is all in the same thread, I don't have to worry about locking and unlocking or any of that nonsense. Now, if the work is empty, I want to do something like this. I want to make sure we're not actually finished. Now remember, in our producer, we have this finished queue. And when we're done, we're going to put out there a true. So I want to make sure we're actually done. So I'm going to say queue equal finished dot get. And we're going to get the value of that finished queue. And I'm going to say if queue equal true. And there's a billion different ways to do that, but I'm just going to just hard code it equals true or is true. Then we're going to go ahead and break out of here. And that'll break out of that loop, and we should let the user know we are, of course, finished. There's really only one thing left to do, the main function. Let's stop playing around here and let's make this thing work. Now, before we really dive into threading, we're going to set some variables here. So I'm going to say max equals 50. This is going to be the maximum amount of work we want the producer to actually produce. Now, we want a queue that's going to hold the work. So I'm going to call it work equal create an instance of the queue class. And I want to be able to signal that other thread on a different queue when we're done. So I'm going to say finished equal queue. Let's go ahead and make a producer. This is going to be a thread. And we've worked with threads before, so I'm not really going to take a whole lot of time to talk about this, but we're going to say the target is going to be the create work function. We want to give it some arguments here. So I'm going to say args equals, and we want our work queue, our finished queue, and the maximum amount of work to produce. And because we've learned a hard lesson in previous videos, we're going to set this as daemon equal true, so this thread will stop running when we stop. Ooh, all right, that is a lot of work here. So let's go ahead and let's grab this whole line. Say consumer. Now, of course, we need to change the target. So we're going to change this to perform work instead of create work. And we have a different set of parameters here. We have work and finish. So let's go ahead and get rid of that maximum there. That one's going to be a daemon as well. Now from here, it's very, very simple. We're just going to say producer.start. So we're going to start the producer thread. Now the producer thread has no idea the consumer even exists. So the producer is just going to immediately get up and start making stuff. Consumer, same thing. It has no idea the producer even exists. These two threads are completely oblivious of each other. They work very independently. So we're going to start both of those. Now I want to wait on that producer. So I'm going to say join. Let's go ahead and display that the producer has finished. That way we know in our main thread something happened. Now we've got a subtle issue here. We need to now wait on the consumer. Now, when we look at the consumer, if we didn't have this little bit here, this consumer will just run forever. So we want to actually have that finish queue there that we put that value in there. I mean, you could forcibly kill the thread when you kill the application, but it's a little rude to just go around killing things. So let's go ahead and say producer. Let's change that to consumer. Whoa, got a little copy and paste happy there. All right, so the consumer joined, consumer finished. And then last but not least, I want to know when the main thread is done. Last line of our application right there. All right, moment of truth here. Assuming I didn't break anything, let's run this. Whoa, that went fast. This is multi-threading at its finest. So let's deep dive and take a look. You can see immediately the producer starts producing and it's kicked out a bunch of values into the queue before the consumers even started. But that's why I put that index there. So producing 0.29, consuming 0.29. And you can go through if you really want to, but it's first in, first out. So it's going to be produce, consume, produce, where is 1, consume 1, there it is. So you can match those numbers up all day, but they're going to be identical. Now, because this is multi-threaded, you're going to see that this thing will start just plowing through this thing at blistering feet. And it's going to say producer has finished and the consumer is still catching up. So now we're just consuming, 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 consuming. That is the producer consumer. Now, if you want to see that in action one more time, let's go ahead and clear this and let's explain this code in depth. So we've got all of our imports, which are, well, pretty self-explanatory. We have a display function, which is going to show us the process name, the thread name, and the message. Now our producer, this produces the work. The first thing we're doing is saying, get a queue, we're calling it finished, and we're going to put a false in there saying we are not done. We're going to do some work. And then after we've done all that work, we're going to change that to a true. That way in the consumer, we can actually tell when we're done. While we're producing, we're going to go ahead and just update the work queue and put that value out there. And we're just going to notify the user we are producing something. Consumer does the polar opposite. We're just going to say loop forever. And then while we actually have work, go ahead and get the next item, display it, do something with it, whatever you want. And then if we're suddenly finished, then go ahead and break out of this. And last but not least, we're going to join those back into our main thread so we don't have to worry about leaking resources, crashing the application, or any of that fun stuff. And the end result is, well, this beautiful little dance of data. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and we're going to continue our journey into Python 3 with communicating with processes. Now, what are we even talking about? Well, we're talking about real-time communications with processes that are running. This is not getting an exit code back. This is taking a process as it's running and sending it information. We can even do this on other machines. That means we can now do multiprocessing across a network. And let's open a diagram here, and let's take a look. So I'm just going to put this rectangle out, and this is going to represent some sort of computer. And then in this computer, we can make some happy little processes that are just churning along, living their little existence as processes. And they may be, just totally oblivious that the other processes exist. Well, what we can do now is we can take some sort of communication channel and communicate with that process. And that is done internally via sockets. This is networking. And so when you say networking, you immediately think, now wait a minute, networking sounds like internet. That's absolutely correct. It gets way more complex than that, but to overly simplify things, and yes, I am drastically overly simplifying things, we can take another computer, and this computer can have its own processes running that are just happily churning away. Whoops, don't know what I clicked there. Happily churning away, and they are oblivious to each other. They're even oblivious to the other machines. We can take this communication channel and move it to another machine. So now you have two processes on different machines that talk to each other. Now, when we talk about networking, there's some fundamental terminology we need to understand. First off, there's something called a server. So a server, in this case, would be this one right here. It's listening for a connection. And the client would be this one over here where it's connecting to the server. You notice the arrow is connecting to the server. Now, that communications can go back and forth, but in this example, we're going to do one-way communications. We're going to cover more complex things when we get into Networking 101, which is very, very soon. Also understand that you can have multiple of these. So for example, you can say, hey, I want to communicate with this guy over here as well. And I want to communicate with this one on the same box. And you can make this as complex as you really want it. Now, the caveat being, though, that once you start using networking, you now have all sorts of terminology and issues and things that you need to understand and other issues you need to work with. For this example, we're going to work on the local computer, but I'm going to try to explain the terminology as I go. And there may be some creative Googling you're going to have to do if you don't fully understand. But this series will cover networking in depth. We're just simply not there yet. Okay, the first step in any program, of course, is imports. I'm going to do a little bit of creative copy and pasting here. So we're going to import logging time because we want to be able to stop the current thread. Multiprocessing because, well, shockingly, we're going to be working with multiple processes. And then from multiprocessing, we want to import process. That way we can get that process name. And multiprocessing context, we want to import the process class. We want to add one more, and I'm going to actually type this out so I can explain it. From multiprocessing dot connection. That connection gives you a clue that we're going to be doing some sort of communication. Under the hood, we're going to be doing TCP communications, or this is a TCP connection. If you don't know what that means, don't worry. We're going to cover it in depth in future videos, but just understand that we are now making some type of network connection. From this, we're going to import the listener. And when you hear the term listener, think server. This is something we're going to connect to. It's going to listen for connections. And we're going to import the client. This is what's going to connect to the listener, or connect to the server, if you will. And from there, of course, I want to configure logging. That way we've got that configuration in there and we don't have to worry about it. It's just going to exist and we can now work with it. Now that we've got the basics out of the way, we're going to work on the worker process. And if you're not familiar with networking, this is going to be vastly confusing. I'm sorry, I will try to explain it as I go along. We've worked with processes before, but this is a little bit different here. So we're going to use a function. I'm going to say def, and let's call this proc. And for now, let's just say pass. That way the IDE doesn't get all mad at me. I want some parameters here. I want a server, and we're going to say, what server are we going to connect to? Now, this is a little bit misleading here because we are going to be the server. So I'm going to say localhost. This is part of what's called an address. So an address is a combination of a server, which can be a host name such as localhost or an IP address, which you've probably heard that term before, and a port. And this is a number. You have thousands and thousands and thousands of ports out on your system. Now, the caveat being someone else may be using a port. There are what's called well-known port numbers. For example, emails like port 25, FTP's port 21, web traffic's on port 80. So if you try to use a port that is already in use, your program is going to fail. There are more advanced techniques where you can find out if the port's in use, but we're just going to live dangerously and just see if it works. Mainly because we're in newbie land and I don't want to do a 3-hour video on networking. So, and then we need some sort of password. And this is not going to be industry strength password by any means. We're going to make some sort of byte, and we're going to say password. Never, never, never have a password of password. Somebody will get into your account very quickly. So the basics here is the worker process is going to start and it's going to listen for incoming connections on an IP address or a server name and a port. These two combined make the address. The person connecting needs to be able to authenticate to us or log into us using a password. This is overly simple. It is not the most secure thing in the planet. This is really great for newbies though. So we're going to say name equals, and I want to know the process, current process, and I want to know the name. From here, I'm going to say logging.info. And in case you're wondering just how complex networking can be, it can get extremely, extremely complex. Python has a couple really, really good libraries out there. I should say libraries, frameworks out there that we're going to cover. And honestly, it'll blow your mind if you're brand new computers, just how complex you can make an application. All right, so we're going to just say that this is started. And of course, I want to know when we're done. So we're going to say finished. Now, in between here, this is where the real work happens. All right, at this point in the function, we are doing absolutely nothing but logging. So let's actually do some work. So we're going to start listening for connections. We're going to take the server and the port and smash them together in one variable called an address. So I'm going to say address equals server and port. There we go. Now that we've got that, we're going to go ahead and make a listener. I'm just going to lowercase that. And the listener is going to take an address, simply give it the variable we just created. And we need an auth key. The auth key sounds big and scary, but really it's the password that we defined up here. Ta-da, this guy. So really it's just a bunch of bytes. And do not ever use something as weak as password. This should be some strong type of password, but just for an example. All right. In case you're wondering why I'm not using a strong password, because if I have something like this, somebody's going to go, what do those characters mean? So it's just very self-explanatory to say password. All right. Now that we've got our listener, we need to do something with that. So I'm going to say connection, or con for short. And we want to accept an incoming connection. I want to be able to see that some type of connection happens, so I'm going to say logging.info. In case you're wondering while I'm typing this, yes, there are frameworks and libraries and all sorts of fun stuff out there, modules that you can do that will replace this functionality probably better than what I'm creating it, but I wanted to show you the foundations here. Connection from, and then I want the listener dot last underscore accepted. And that'll tell us who actually connected to us. Now that we've got some type of connection here, we are going to loop for input. We're going to basically monitor that connection and wait for some specific command from the remote process here. I'm going to say while through message equals, we want our connection, and we want to receive. So we're basically saying, hey, connection, block until we have some type of data here, and then notice this is a pickleable, say that real fast, pickleable object. We've talked about pickle in the past, but under the hood, Python is taking an object, serializing it with pickle, sending it across the TCP wire, and then deserializing it and handing it back to us in the form of a variable that we are going to call message. And now we're going to say logging.info, just because I want to know what's going on under the hood here in case something goes kaboom. Name, and I want to say data in, and I want to see the actual message that was sent. That way, if somebody sends gibberish, I want to know. Now, you can do all sorts of commands. You can do pretty much anything we want, but I'm going to say if the message is equal to quit, just the string representation of quit, I want to say connection close. And what this does is it takes that connection between the client and the server and closes it. Think of it like you're on the telephone with somebody and the conversation's over. You're hanging up the phone. That's literally what we're doing here. We're breaking that connection. There will be no more communication between the client and server once we do that. Then we're going to break out of this loop. And once we get back here, we're going to say listener dot close. So now we're going to actually close the server down. Notice those are two distinctly different closes. Here we're closing the connection. Here we're closing the server so no one else can call us. That's like ripping the phone out of the wall and throwing it across the room. All right, so quick recap before we move on. Really what we're doing is we're going to start listening for connections, and then we're going to loop for input from that other connected process. It's going to send us variables, or I should say data, that has been serialized using pickle. Now let's work on our main function, and I'm going to break this down into a couple little segments here. So we're going to go here, main, and this little segment, I'm just going to flesh out the template for main here. So we're not going to win any awards for this code, but it'll still be cool. Why not? And we can just, for the sake of time, plop in some stuff here. I'm going to grab him. Do the magic of copy and paste. And now we're going to start fleshing this thing out. We're going to do this in a few different steps. We're going to set up a process, connect to the process, and then clean up after we shut that process down. Okay, step one, we are going to set up the process. And I want to start off with, we need an address, a port, and a password. So I'm going to say address. And this is where you would put the actual address. Now, if you are somewhat skilled in networking, you say, hey, I'm going to use my buddy's machine, and you're going to say, 19 whatever their IP address is, blah, 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 blah. You may have a bunch of problems because they may have a firewall, they may not have a port open on their router, and all these other networking things that we haven't talked about are going to happen. So no, you're not going to have uber hacking skills after this video, but you got to start somewhere, right? So we're going to say localhost. Now, when we see localhost, what are we really connecting to? That's our local computer. Now, under the hood, you have an address that looks something like this. That's called a local loopback. So when you see localhost, that is actually the exact same computer that you're currently on. So don't ever really get confused. You're not going out and connecting to another system somewhere. Now, from here, we want a port. Now, the port is a little confusing. Every host, whether it's local or otherwise, has thousands and thousands of ports. Some are available, some are in use. So we're going to pick a port that we're fairly confident is not in use. So I'm going to say 2923. There's a much better way of doing that we're going to cover when we get deeper into networking. But right now, just kind of leap of faith that there's nothing running on port 2923. Special note on that, if you get like rejected or denied or port in use, that's probably the number you're going to have to change. At that case, just go in here and randomly change it to another number. I would keep it above 1024, and I'm going to actually put that in the notes. Because anything below this number is what's used as a system port. This would be things like email, web services, and things like that. So you don't want to go below that 1024. And honestly, I would go above 2000 just to make sure, because every computer is going to be a little bit different. And if you have a virus scanner or something like that, it may actually pop up and say, warning, this thing is trying to communicate on the internet. Just know you're not hacking yourself or anything like that. So you would not believe some of the weird questions I've gotten over the years from these kind of tutorials. So from here, we need something super snazzy and top secret. This is just 8-byte representation of some sort of passphrase. You can put whatever you want, but this password has to match whatever we're expecting over here. That's the auth key right there. So once we've got that, now we can go ahead and actually start the process. So I'm going to say p equal process. And I want the target to be our function. And I want the args, always love that word, args, to be the address and the port and the password. Now we also want to set this to a daemon. That way it'll, whoops, what did I do there? Oh, good gosh. All right, we want to set that to a daemon. So if we shut this program down, we want everything to shut down with it. We don't want some rogue process sitting there churning away. And let's go ahead and give it a name just because we can. Looks mean, ugly, and scary, but we've covered this in other videos. And we don't need two equal signs. I just horribly screwed that whole thing up. So anyways, we're taking a process class. We're going to say your target is going to be this function up here, our worker process. The args are going to be the address, localhost, the port. In my case, I've got 2823. Choose whatever you want. And some sort of password. Now, you should do a whole lot more than what we're doing in this video. We're just covering the basics. We're not covering like high-end authentication or anything like that. So I'm going to say start. This is going to start that process. Logging.info. And let's go ahead and say name. Waiting on the worker. And there's various ways we could do this, but I want to have you understand why I am going to put this to sleep. We're going to sleep for exactly 1 second. The reason why we're doing this is we're doing two things rather quickly. We are starting a process, which takes time. And in that process, we're starting a listener and waiting for connection. So now we're communicating with the operating system and the TCP stack under the hood and saying, hey, pretty please open up a port on this server. All of that takes time. Granted, it happens very, very quickly, but I'm just going to say, go to sleep for 1 second while that process loads up. You can try things like, is alive and all that other stuff, but you're going to run into some weird timing issues where one time it works and one time it doesn't. So sleep for 1 second, because 1 second in processing time is an eternity. All right, now at this point, hopefully we've got a process that's running, and that process is hopefully listening for a connection. We're going to go ahead and connect to that process. So I want to say I need some sort of destination, and this is going to be a combination of our address and the port. It's virtually identical to what we did up here. We're just using different variable names so people don't really get super confused. So we're going to take that destination, which is a combination of the address and the port, and we're going to say, make a connection object. That connection object, we want to do something super, super fancy with. We're going to say, we want to make a client, and we want this client to connect to that listener on that destination. which is a combination of the address and the port. We also want to give it the auth key. In this case, it's going to be that password, that byte representation of a passphrase that we set up here. This has to match. If it does not match what we started our process with, we're going to have a bad time. So what happens under the hood is, well, magic at this point. We haven't really talked about networking and TCPing, but what's going to happen is the computer is going to go out and it's going to try to connect to that remote listener using the destination address and port. If you have any problems, this is where you're going to start getting errors. So we have a process, we have a client, we've connected to them. Now we need some type of command loop. And this is very simple. We're just going to ask the user, hey, what do you want to send to the server? So I'm going to say, while true. I'm always envious of these guys who can like type and talk at the same time, because I am not that guy, to be brutally honest with you. I'm going to say input. If you've watched my videos, you see me make just horrendous spelling mistakes, and I apologize, but it is what it is. All right, so we're going to hard return line feed, and then in here, I want to say enter a command or type quit. We're going to go ahead and take that. We're going to say strip because we want to make sure there isn't any white space after that. Python's not a big fan of white space, and neither am I. And then I'm going to say logging.info, and we want to know what we're sending. So I'm going to say f name command, and then our actual command so we can see what we're sending out to the server. And then we want to actually send it. So I'm going to say connection.send, and we're going to send that command. That's just a string, so it's nothing fancy. It's just going to shoot it out. Now, networking is actually highly, highly complex. If you're ever super bored one day, take a networking class. You'll be overwhelmed very quickly. But there's a lot of complexity under the hood. All we need to know is that thing sent without a problem. And then we want to see if the command was quit. Then we're going to go ahead and break out of this loop. And we're going to move on to the next section, which is clean up and shut down. All right, last step, we are going to clean up and shut down. And this is, well, dead simple. So I'm going to say if the process is alive, then I want to try to gracefully terminate that. So we're going to say logging.info. And I want to say name terminating worker. That always sounds so harsh. We're going to terminate something. Anyway, so we're going to say connection.close. So we're going to try and gracefully close that connection. I'm going to go ahead and say time.sleep. There is vastly better ways of doing this, but I'm just showing you the very newbie way of doing it. What's happening under the hood here is if we enter quit, we're going to break out of this event loop. So we want to, well, wait for that process to terminate. So if it's still alive, we want to close that connection down, give it a moment, and then, you know what, if it's still going, no more Mr. Nice Guy, we're going to completely terminate it. From there, we're just going to say p join back into our main process here. All right, so a lot happening here. If this seems complex, it's because it's bigger than anything we've done in this series so far. But really what we're doing is we are starting a process. That process is going to run, and it's going to have a listener inside of it. That listener is going to accept connections. That connection allows us to send real-time commands to it. We can take those commands and read them and act upon them. If we send quit, it's going to close that process down and terminate our program because it's going to exit out of our command loop here. All right, moment of truth. Let's see this in action here. So let's move this up and let's run this. So main process started, main process waiting on the worker. The worker has now started. We have a whole new process running. And then here's our command loop right here, enter command or type quit. And you can see the worker connection from this. Now this is a little confusing right here. What is this guy? This is why I wanted to split this out into a different section. So localhost, remember how I said it is 127.0.0.1? That's your local loopback. So basically what we're saying is connect to yourself. There's something in the background called name search order or DNS. And basically, I'm going to drastically oversimplify this. It's going to take a name and turn it into a number. And under the hood, it's smart enough to know that localhost is this number here. So when you go to like Amazon.com or Google.com or Apple.com or something, there's some sort of naming convention going on there where it's doing a name lookup. 99% of the time nowadays, that's DNS, but it's basically saying under the hood, translate a name into a number. Now you notice the port is different too. We have port 2823, and here it says 60952. Every source and every destination have two different ports. So our source is this guy right here. What happens is under the hood, the operating system tells Python, let me go get a free port that you can talk on, and it hands it this number. It's a lot like me handing you the telephone and saying, here you go. It's not your phone and you have to give it back, and if you don't, I will come find you because I really like my phone. However, the person on the other end of the line, the actual listener, they already have their phone and they're ready to go. So that's why you have two different port numbers. Just understand you can't have the same port number on the same machine at the same time or you're going to have very big problems. All right, back to demonstration land. We need to enter a command. We can just simply enter cat or whatever you want. And you see the main process command cat, and then it sends it across the network and the worker says data in cat. That is extremely cool. Now you may be wondering, because this is all on my local computer, is this actually going across the internet? The answer to that is no. Your TCP stack on most operating systems is smart enough to know that this should be self-contained because it's all on the local network here. Let me see if I can highlight that. If it's local, it should never actually go out to your network. But you could very easily run this script out on another network machine with some minor tweaking and get it to load up just fine. Now I'm going to go ahead and shut this down. So I'm going to say quit. And you notice how our main process command quit. We're going to terminate that worker. The worker's got a data in of quit, and then the worker finished. There is a slight delay here, which is why I put all those times sleep. If you take those out, you're going to start getting some weird errors. And then finally, our main process is finished. This is pretty complex, but Python makes it extremely easy compared to other languages and other frameworks. The main takeaway here is that you can start a process even on a remote machine and communicate with it in real time. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. All right, welcome back everyone. This is Brian. We're talking about networking basics. This is basically networking 101. We're going to make a TCP client. Now, what is TCP and what is a client? Well, I'm glad you asked. I'm going to paste just a humongous amount of information on the screen and we're going to go through it super quick. So TCP stands for Transmission Control Protocol. It's basically a standard that defines how two machines are going to talk to each other on an IP or Internet Protocol network. A lot of this sounds super confusing, and you start hearing things like three-way handshake, and you're like, wait, what? They're shaking hands? Are they friends now? Okay, we're going to dial this back all the way to newbie land. You have a server which listens for incoming connections. Think of this like somebody sitting next to a phone waiting for that phone to ring. When that phone rings, the person on the other end is going to be speaking a language called TCP. The client is the person who calls the server and is speaking TCP. They both have to speak TCP to talk to each other. Now, once those two start talking, they form what's called a network. A network consists of two or more computers that are linked. When you hear the word linked, really what we're talking about is they can talk to each other. It doesn't matter if they're talking to each other over a physical line, a satellite communication, cell phone network. It does not matter. Now, to pull off this feat, they have to use what's called an IP, or an Internet Protocol, which is another protocol. Protocol just defines how things talk. An IP is a number that represents a machine on that network. Think of it this way. You have two people talking to each other. How do you know which one is which? Well, you have to name them somehow. So that's really all this is a number that represents that machine. You can have machine 1, machine 2, machine 500, doesn't really matter. You'll also hear terms like IPv4 and IPv6. So 4 was the fourth version of that protocol, and at the time they thought they had way more addresses than they would ever use. Well, fast forward and modern times, we are running out of IP addresses. We have so many devices, we are simply running out. So to combat that, they have made what's called IPv6, which will allow everything in the known universe to have multiple IP addresses. You could have networked meteors, for crying out loud. I mean, it's just a massive amount of numbers. Now, you're going to hear things like a port. So basically, every computer can have multiple IP addresses or multiple numbers that identify them on a network, or networks, plural. But each IP can have multiple ports. A port just defines a channel between those machines where they can talk. This is what I mean by it gets confusing. We're going to break it down a little bit simpler, but understand a port is just a communication endpoint that is talking on an IP. The IP is on the network, which belongs to these guys right here, the server and the client. Now, once they're connected and they start talking, they have to use what's called a protocol, which defines a mean of application communications. So what we're talking about here is, let's say client calls server, but client speaking English and server speaking Japanese. They're not going to understand each other. They need a predefined protocol, which they both agree upon and they both use. All right, so this is a good visual representation of what's going on under the hood. And you as the developer will not see any of this, but you need to understand what's going on. You have a client on an IP address that uses a port, and a server with an IP address and a port. This could be the same machine or a different machine altogether. For example, I have 120 and 195. These are two different IP addresses. The client is going to send a SYN, which is just a special number. The server is going to send that number back with another number called an ACK. Now, when it sends the SYN back, I do believe it sends it back modified so the client knows what to expect. The client's going to take the ACK from the server and modify it and send it back. That way they both know they're talking correctly. They know what to expect. It's kind of like they're challenging each other to give each other the secret answer. Once they both agree, communication is born. And communication can go both ways. You can send and receive data. The first step in any application is, you guessed it, include. So we want to include our logging, and we want socket. From there, I'm going to go ahead and let's configure our logging. And in case you don't know what any of this stuff is, I highly encourage you to rewind the playlist and watch the previous videos, because I've talked about logging in depth. Socket's brand new, but we've really hammered out logging. The next step is we're going to actually create our client. And this may sound horrifying, but it's actually very simple. In the spirit of Python, it's very, very simple. So I'm going to say def. I want to make a function called download. And we're going to have a server and a port. Really very simple. From here, I'm going to say s equals socket. And I want to make a socket. From here, we need a family. Now, what are we talking about family? Remember, there's different types of addresses. So I want to say socket dot address family underscore inet. You see there's inet and inet6. When you see inet, we're talking about IPv4, which we talked about in the previous section. We're going to use IPv4 just because it should work on just about everything. From there, we want to define how we're going to talk. So I'm going to say socket dot sock underscore stream. Now, this may look like voodoo magic, and you're going to have to take it almost on a leap of faith of what's happening here. But really what we're saying is define a TCP socket using an IPv4 address, and we want that directional communication so we can talk back and forth in a stream of data. All right, now that we've got this, we can go ahead and say our address. We're going to make a tuple. Just going to be the server and the port. Let's go ahead and say logging.info. And I want to say connecting to our server and our port. And we're simply going to say s.connect. Now this will block. Now this is pretty helpful for newbie entry level, but we're going to do non-blocking in the future. But your application is actually going to stop executing at this point. So I'm going to say s.connect, and we're going to connect to that address. Spoiler alert, this could actually crash your system. We're not using error handling in this video. I just want you to be aware of that. So if you have some sort of crazy error, it's probably because you've chosen a server and a port that is not listening. So we're going to say logging.info connected. Once we've gotten to this point, I want to say logging.send. Oops, I'm sorry. .info. Got a little ahead of myself there. Just so we know what we're doing. Now we're going to say s.send. Got a little ahead of myself. So this is where we have to define what we're going to send to that server. We're assuming that three-way handshake took place right here in the s.connect. All of that happens transparently under the hood. But I want you to understand why all of that terminology we talked about exists. Because if this fails, that means that three-way handshake we talked about failed. We're just assuming we've gotten to this point and they've shaken hands and they're now talking to each other in TCP and they know how each other speaks. So we're going to send some bytes. We're going to say hello /r/n. So what we're really doing here is we're just sending data. We're not really following any sort of protocol. This is a little dangerous because what if the end server doesn't know what to do with this? It could potentially crash that end computer, and that actually is a cyber attack where you just send a server a bunch of junk data and watch it die. You have to be a little bit careful when you're in socket land because you can do some really bad things on accident or on purpose. So I'm going to say logging.info. And we're going to go ahead and receive some data. So I'm going to say data equal s. And I want to go ahead and receive up to a maximum of 1024 bytes. That's our buffer size there. So when you hear buffer, really what we're talking about is a bunch of data and it's limited in size. We don't want to go over that because you can have what's called a buffer overflow, which is a very bad thing if you ever have that happen. But basically your computer would start interpreting that data as raw commands and try to execute it. You don't want to do that. So we're going to limit that buffer here. And now I'm going to say, now that we've gotten that data, we're going to go ahead and close this connection down. So I'm going to say logging.info, just so we know what's going on here. Closing. And I am overly simplifying this. There may be some folks in the comments that say you really should shut down Graceful first, but I'm just going to slam that door shut and let the server figure out what we're doing. And then I'm going to say logging.info. And we want to know what data we got back from that server. We're just assuming that this whole thing just worked. And there we go. It's really not that hard. Here's our client in all of its glory. We're making a TCP IP4 socket with a socket stream. We've got an address of the server and a port. We're going to connect to it, assume that three-way handshake works. We're going to send it some data. We're not really talking about protocols yet this early in the game. And then we're going to receive some information. Now this is going to block, so we're going to just sit there and wait for the server to send us at least 1024 bytes. Then we're going to close that socket down. Whenever you open a socket, whether you're listening or connecting, you want to make sure you close that resource because this is happening in the operating system, which is talking to your network card. You want to make sure that resource is not left open. And then we're just going to print out on the screen whatever the server sent us. Now that we've defined our client, we're going to go ahead and use it. So I'm going to make a main function here. And we're just going to simply call our function. I'm going to say download. And what are we going to download here? Well, this is where some decisions need to be made. And I'm going to use my own website, voidrealms.com. I really need to update that website. And then we're going to use a port. Now, if you know anything about networking, what we're doing is we're going to a website and we're connecting on port 80. Now, this may or may not work. What may happen is we may get some information back. We may get a connection refused. So for example, if I use a port that server is not listening on, like something like this, it's going to have very, very bad consequences. However, I'm very convinced that at least it should be up and running, or I need to call my ISP and say, what the F, guys, come on. So it's listening on port 80, which is the standard protocol for websites, or HTTP protocol. Now, notice I said protocol. We're not sending information in a protocol. We're just slamming it with raw bytes. So the server here may come back and say, you know what? I have no idea what the hell you're talking about. Go away. It may not even respond. It may just close the connection. And you're going to get different results with different servers, as we're about to dive in and find out. So let's go ahead and run this, see what happens. All right, so you can see connecting to voidrealms.com on 80 connected, send, receive, and it's just hung. It's not doing anything. There we go. So what happened there was my server said, uh-oh, HTTP protocol 11400 bad request. Meaning, I have no idea what you're even asking me, bro. Why are you even talking to me? We're not speaking the same language. So this right here is actually a protocol. This is called the HTTP protocol version 1.1. And 400 defines that it was a bad request. And then you get into the very specifics of that protocol. Every protocol is different. Not every protocol is what's called human readable, meaning HTTP is very forgiving. We can pull it up on the screen and read it. Now, if you don't know HTML, that's what all this weird stuff is. These little brackets and in brackets, it's all HTTP. This is a web page that we just downloaded. Interesting how this works. So let's actually switch servers here. Let's go from voidrealms.com to youtube.com. And let's do on port 80 and see what happens here. I'm going to go ahead and clear this out. And you notice same thing, much faster though, because YouTube has a lot more money. HTTP 10400 bad request content type, and you get a much different response back. So when in doubt, understand what you're doing here. We are actually connecting to a system and getting information back. But to correctly talk to that system, we now should use some sort of protocol. Now, in the beginner videos, we're going to be defining our own protocol, and then as things get more and more complex, we'll be using industry standard protocols. But I want you to really understand what happens here. And let's flip back to our buddy, my server, because I don't want YouTube getting mad at me for doing something. I'm going to set it to some port that I'm fairly confident is not in use, and I'm going to just pick a number. I don't have a clue if that's even open. I don't think it would be. We're going to try this. And uh-oh, we had an error. So you notice how right here, connection refused. So what's happening here is we're going out to that server, we're performing that three-way handshake, and it's saying, you know what? That port's not in use. I'm going to refuse that connection. So that handshake now fails, and it sends back the information. And then it goes up through the operating system and into Python, and Python tells us, hey, connection refused error. I want you to really understand what's going on there, just in case you try doing something like that. Now let's try doing something like this. I'm trying to think of a good one. Blah, blah, DZ24.net. I don't think that even exists. Let's clear this out. And we got a different error. Name or service not known. Basically what we're saying is it couldn't even find that remote device because this probably does not exist. Although if you got money, you might want to go out and buy that domain name before it gets super popular, because blah blah ZZ24 sounds really snazzy. But I want you to understand the different types of errors you're going to get back, just in case you're playing around with this and you can't figure it out. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to be talking about the other end of that communication channel, the TCP server. And I'm just going to paste a whole bunch of information in here. It's the exact same thing from the previous video, just in case you skipped it. We're going to be using TCP. We are going to be the server, meaning we're going to open up and listen for clients to connect to us. Doing so creates a network. We're doing this on IPv4, and we're going to use a port. And we really don't have a protocol, but I want you to understand, by sending information back and forth, we are essentially creating our own protocol. All right, let's dive in and take a look at what we're really doing here. So previously, we were the client where we connected out to a website and the website sent us something back. In this case, we are the server. So something else is going to connect to us. We are going to take that information and do something with it. I know I've said it before, but the first step is always to, well, get our includes hammered out. So we're going to import logging socket, and let's go ahead and let's configure our logging real quick here. I know I've covered this before time and time again. I just don't like skipping steps because then people go, now wait, when did that get configured? So we've covered this to the point of being ridiculous, but you should know how logging works at this point. But we're going to be using sockets. So when we use this module, understand what we're doing. We're working with IP protocols. Let's go ahead and define our server. So we're going to do this in a function. I'm going to say def, and this is going to be server. And this is going to be what's called a blocking server, which means it's going to block this thread while it's talking. This is not what you would consider high performance or industry standard. We're just doing this so you can get the basic fundamentals down. We'll make a non-blocking server later on in the series. So we want an IP that we're going to use and a port we're going to talk on. Now, think of an IP like a phone number. You can have multiple phones with multiple phone numbers and things of that nature. So we just want our identifying number on the network and the port we're going to use to talk on. From here, I'm going to say s equals socket. And I want to say socket. I always like saying that. Socket, socket. Anyways, socket to me. Anyways, let's go ahead and say socket dot. And we need an address family of INET because we're using IPv4. We've talked about it before. IPv4 and IPv version 6 accomplish basically the same thing. They just identify your machine on a network. And then we want to say socket dot sock stream. Sock stream. That has like a weird visual when you think about a sock stream, like a stream of socks, kind of like my laundry basket. But really, it's kind of the same concept. You have a stream of data that's coming across that socket. Now we're going to say address equals, and we want a tuple here. That tuple is going to be our IP and our port combination. And I'm going to say logging.info. And this is strictly for us, just so we know what's going on in the server. Now, server's a little bit different. We're not going to connect to something. What we need to do is bind. Now, usually when you're in a bind, it's not a good thing, but here it is. We're going to say s.bind. So we're taking that socket and binding it to the address, which is a combination of the IP and the port. This could throw an error. If we try to bind something that either the operating system doesn't want us to do because we don't have permissions or it's in use by something else, it's going to come back with an error. But basically what we're doing is we're telling the operating system, we are now using this and no one else can. From there, I'm gonna say logging.info. And let's go ahead and flip these around. I want to just kind of in real time making a decision here on how I want to handle this. Just so we can see the IP and port we're binding to. Then we're going to flip around and say, you know what? We are now going to listen. So once we've bound to that address, which is the IP port combination, we're going to go ahead and say socket.listen. And this is a lot like sitting next to the phone and listening. And we can tell it how many things we want to listen for. We're only going to listen for one in this example. So only one thing is really expected to talk to us. From here, we're going to go ahead and say we want a connection and the address of s.accept. So what's happening here is our socket, somebody has dialed our phone and we are going, oh, I will pick it up. I want to know who that person is based off their address, and I want the connection object or the underlying socket used to talk back and forth. Pretty simple the way that works, but it may look a little confusing on the screen. Now I'm going to say logging.info. I should probably tell it that we're formatting it. This is what happens when I change my mind halfway through a video. All right, there we go. So we're going to say connected. And we want to know the address of that remote connection. From there, we've got a huge amount of decisions we need to make here. But I'm going to say, I want to do this in a while loop. So I'm going to say while true. And we're going to say data. We want the connection. I'm going to go ahead and receive some data here. So what we're going to do is we're going to block our socket or basically say we're not going to do anything else until this socket gives us data. This is called a blocking socket. So the whole application is going to come to a screeching halt when it hits this line, and it's going to wait for some amount of data all the way up to 1024 bytes. Then I'm going to say if len, and there's multiple ways to do this. You could say if not data. I like doing this, if not len data equals 0. So if the length of data is equal 0, then we're going to go ahead and get out of here. We're going to go ahead and close that connection. And we're going to go ahead and break out of here. Now at this point, pretty much the connections are already shot anyways, because basically what we're saying is if the client didn't send us anything, then go ahead and shut everything down. We're just trying to very gracefully do it on our end, even though the client may have just logged off or died. We just don't know. So let's go ahead here and we're going to say logging.info. And we want to know what they sent us. Once we've broken out of this loop, then it's just very simple. We're going to say logging.info. And we need to take that server socket and let's close it. So we're going to stop listening. This is a lot like just hanging up the phone and walking away. Because we've listened, we now need to close or hang up that phone. But we have to also close that connection. So understand what's going on here is technically we have two sockets. We have our server socket, which we've bound to and we're listening on. And then as somebody calls, the operating system is handing us another socket that we can work with and receive data from. And when we're done, we need to try to close that out gracefully. All right, the moment you've been waiting for. Let's go ahead and do our main function here. We're going to actually work with that server socket. So I'm going to say main, and let's go ahead and make our main function. And we're going to say server, and we have an IP and a port. So we're going to use our local host, which is just a representation of our local system. And I need to pick a port that is not in use. And later on in the series, I'm going to show you how to find a port that's not in use. But right now, I'm just going to guess. So I'm going to say 2607. I have no idea if that port's even in use. This may have disastrous consequences. So if we choose a port that is what's considered a well-known port, which is less than 1024, we may say access denied and our program dies. And that's because those are considered special ports. That's why I'm going to go with, what did I say, 2607, just because it's above that number. All right, let's go ahead and run this. And you can see how we have bound to localhost on 2607 and we are listening. That means we successfully went to the operating system and says, pretty please open this port up and let me own it. And it said, sure, there you go. And now we're listening for information. So I'm going to move this up here. And we are going to open a command line. I want to do this outside of Python. That way you can see just how squirrely things can get. So I'm going to go with what's called telnet, which is a program. And I'm going to say 127.00.1, which is the same thing as localhost. And let's go ahead and connect on 2607. You can see how we now have a connection. And I'm going to try and move this over here. So connected 127.0.0.1, and then we get this port number. So this is the alternating endpoints. So our server is listening on 2607. The client is connected on 60448. A little confusing how that works, but think of them as two different objects because they are. Then I'm going to say hello. And you can see we have some data in. Hello. Let me move this down here. Now, I should note, depending on your telnet program that you use, if you're testing this out yourself, you may actually see each individual keystroke as you do this. It may get a little confusing as you're going to see HELLO going down the screen. So basically, in my representation, the data is not sent until I hit the enter key. So I'm going to say, hello world. And as soon as I hit enter, it sends it and it adds a carriage return line feed to it. Now I'm going to actually close this window, and this is where we'll get unpredictable results, because in our protocol, the language these two are talking back and forth on, we haven't defined when it should shut down. So I'm going to just close the window, and it's gracefully exiting and closing the server. Now on some systems, you may get a big wad of weird looking bytes, and that is basically the end program not shutting down gracefully and the client doesn't know what to do, or there was still data in the buffer, or some other crazy thing happened. So end to end, really what we're doing here is we're saying bind to an address and a port locally, listen, and then wait for a connection. Once we have a connection, go ahead and receive that information until we can't receive it anymore because they stop talking to us. Then we close that server down. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. We're going to continue our journey into Python 3. In this video, we're going to determine if a port is available. In the past few videos, we've kind of used a port number, and we haven't really cared if something else has used it, so you may have actually crashed your script and had to have switched over to a different port. There are thousands of different ways of doing this, but I'm going to show you one simple, easy technique that everyone can understand using the information we've learned in these videos so far. And you may have to do some creative Googling. I'm on Linux, but of course, Python runs just about everywhere, so you may have to Google how to find ports in use for whatever your OS is, whether it's Mac or Windows or whatever you're using. For Linux, I'm going to use the lsof command, and it's going to return something like this, which is going to say a process along with who's running it, whether it's IP version 4, IP version 6, And then it's going to tell us TCP because we're listening and we want to know the port. The main takeaway from this is, let's say I wanted to open something on port 631. I can't because CUPS is running on that. It's listening. There's an actual TCP server listening on that port. So if I go to use that port, it's going to, well, crash my program. The first step in any program is, of course, to import. So I'm just going to copy and paste. And we've got logging and socket, and then I'm going to configure logging. That's right. It's really that simple. We're going to keep this nice and short for this video. I want it dead simple to understand. All right, the bulk of this video here, we're going to check one port. We are going to later on in the next section check an entire range of ports, but we're going to reuse a function over and over again. So we're going to make this function. So it's going to be called check_port. And initially I'm just going to do a pass, and I'm going to say IP, port, and timeout. And I'm not a professional typer, so you're going to watch me make a lot of mistakes. I apologize in advance. I'm only human. I always get envious of these guys that can type and talk and do all these great things at once. I am not one of those people. So we're going to say logging debug, and we just want to put some debug messages just so we know exactly what we're doing here. I've actually heard from a friend of mine that they don't actually type most of the time. They actually have a program that's typing for them. So I thought maybe that would be a good Python project for me, would be an auto typer so I could talk while it's typing for me. But alas, we haven't done that. So we're just going to watch me do my horrible typing. Now we're going to do a try block here, and we want try except finally. And let's go ahead and make this as exception as EX. Now I'm going to do this a little bit backwards here. The main goal is we want a value to be returned. So no matter what we do, we're going to return this value. So our immediate goal is to set this value based off what's going to happen. So we want to return a true or false whether or not the port is, well, in use. So let's go ahead and figure this out. Again, I'm going to do this a little bit backwards here. I'm going to do the finally first. So let's grab this. And I want to say returning IP port equals, and we want to know what value we're actually returning. Then I'm going to grab this. Let's say error. And then I want to know what kind of error actually happened. Now we can, if we really want to, just in case we are super worried, we can actually set that to false right there, just in case. Now let's look at the bulk of our code here. We're going to say s equals socket.socket. And this is going to be a socket in the address family of INET or IP version 4. And I want to say socket, and we're going to use a sock stream. Sock stream is a representation of TCP. So now that we've got that, I'm going to say socket dot set default timeouts. We're going to set the default timeout for our sockets. Now, if we wanted to, we could actually do it on the individual socket itself. Set timeout. I'm going to show you both ways of doing that. So I'm going to comment that out just for giggles right now. Now what this does is it says if it's having trouble connecting, it's just going to immediately time out after a given time frame, and it's going to say, nope, sorry, couldn't do it. Now from here, we're going to say we want a connection value. This is not an actual connection. And I want to say s dot, so we're saying socket, connect underscore ex. You notice there's two different connects. There's connect, and connect itself, we've used this before. This will connect to a remote host. We want connect ex. And what connect ex will do is it will give us an integer back, not an actual socket. It's going to say, hey, here's the end result of that connection attempt. It's not going to break our program if it can't connect, is what I'm getting at here. It's going to give us an integer back saying, yes, I could, or no, I couldn't. All right, so we need an address, so I'm going to just make a tuple. And I'm going to say IP, comma, port. Now that we've got that, I want to know what the end result of that was. So I'm just going to grab this. And let's just print out the connection status. And again, this is going to be an integer of some kind of number representing what actually happened. Now, we do have the socket lingering here, so we want to go ahead and close this. Again, this is all wrapped into a try block, just in case something goes boom. Now I want to say if on equals 0. That means, yep, sorry, couldn't do it. And I'm going to just, for the sake of speed here, do a little bit of copy and paste on my notes. Try and speed this up. It's pretty self-explanatory what's going on. All right, so if we get a 0 back, that means in use. If we get something other than 0, it is usable. Seems pretty straightforward. Let's go ahead and flip into this. And we are going to now check a range. Okay, we're going to take this function we just wrote, check port, and we're going to wrap it into a range of ports. So instead of checking just one port, I want to be able to check an entire range of ports. So we're going to reuse that function. So we're going to say def check underscore range. And I want the IP and a scope. And there are, again, thousands of different ways of doing this. I'm just showing you one way. So if you go to Google, you're going to find millions and millions of different answers on how to do this. I'm going to say for P in whatever that scope is. And that, if you're wondering what scope is going to be, it's just going to be a range object. Now in here, I'm going to say the result equals, and we're going to reuse our check port function, which we just wrote. We need an IP, a port, and a timeout. So we got the IP. We're going to grab that individual port, and let's go ahead and give it a timeout of 1 second. From here, I want to build up our dictionary. So I'm going to say ret, and we want to know that port had a specific result. And then let's go ahead and return our dictionary object. So what this is going to do here is we're going to give a range. Let's say we could do like between port 1000 and 2000. And it's going to go through each one of those and check each individual port and see if you can connect to it. So if you can connect to it, it's in use, meaning another program is using it and you don't want to try to use it. So we're going to say, no, you cannot use that. However, if it's usable, we got an error trying to connect to it, that means there's nothing listening to it, then we can actually go out and try to bind to that. Now, there are other things as well, but this is really fundamental. We just want to know, can we attempt to use it? Doesn't mean we're guaranteed to use it. It just means we don't think beyond a reasonable doubt that there's something else out there using it. And check range is just going to go through a range of port numbers and check all of them at once. All right, the part that I often get excited for, let's go ahead and see it in action here. So we're going to make our main function. I always screw this up because I get so excited. All right, so let's go ahead and test one port. We're just going to try this out. So I'm going to say P equals, and I want to check port. And let's check our local host, which again is just our local computer. We're not going out to the actual internet to do this. And we're going to check, I'm just going to make up a port, 2594, why not? And we're going to say, you know what, I want a timeout of 2.0. Could have just said 2, doesn't really matter, but point being, we're going to go to the local host and we're going to check this port 2594. I have not a clue if anything's even running on it. Actually, we can pull up our command line. I don't think it's on there, 2594. I'm not seeing anything, so this should actually say it is usable. Let's test it out and find out here. So I'm going to say logging.info, and let's format this. And I want port what did we say here? 2594 usable. And then we just want to know that end result there. So let's go ahead and test this out. And it's going to say port 2594 usable true. So reasonable suspicion, we can conclude that we should be able to use that port. Now let's go ahead and do the same thing, but instead of one port, I want to do a range of ports. Uppercase that for consistency so somebody doesn't yell at me. I get some squirrely comments sometimes where somebody's like, I hate the way you type, or I love the way you type, and I'm like, I'm sorry, I just type. All right, so we're gonna say local host, and we want to do a range, and let's pick a good range here. So here we've got some ports we know are in use, right? So like 53. I like this 3306, which is MySQL. We got some Dropbox. So let's pick on this little guy here, 3306. So we're going to say copy that. And let's go. I know that port's in use, so let's go to 9. Just get a very short range here. This will return back a dictionary object. Go ahead and clear that out while I'm thinking about it. And then from here, we're going to say for key, comma, value in ports dot items. And we're going to say logging info. And I want to say port, whatever the key is. And we'll say usable. I almost just kind of took the easy way and put an equal sign there. All right, so we're going to go through that whole range there. Now we're doing a very short range just for demonstration. You could definitely do the entire machine if you want. You may get access denied and some other things depending on your operating system. So you got to be a little bit careful when you try this. Let's go ahead. Uh-oh. Ah, see, from. Or, I told you I was going to make a mistake. There we go. So we can see that 302, and let's scroll up here. So it starts at 00, usable true, 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 and 3306, usable false. Let's pull this up, see what's on 3306. And you got it. It is MySQL. So that is really kind of the main takeaway here, is that you can really quickly determine if a port is usable. And you can even check on a range of ports. Now, in the real world, honestly, you don't do this very often. You don't do this because you're going to let the user define what port or what port range they're going to work on. It's not really up to you to say, I'm going to go find a free port. Now, there are some practical applications of this. For example, if you have some graphical interface and the user keys in what port they want and they hit enter, you want to go out and check and, be a little nice to the user and say, I'm sorry, something else is using that. We need to pick another number. That's really the main takeaway out of this video. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian. So in this video, we're going to dive deeper into Python 3 using UDP sockets. We've talked about TCP with their 3-way handshake. So what is UDP? Well, UDP doesn't have concepts like connections and clients and servers. Think of UDP like as a room full of people and everyone's just shouting at the same time, and you have to kind of select who you want to pay attention to. So UDP is User Datagram Protocol. Notice the first word, user. That means it's up to the user to determine the protocol. There is no three-way handshake or any fancy thing like that. So this is a communications protocol that's used for establishing low latency and loss tolerating communications. Now, what does this mean? Low latency means this is very fast, but it's also very dangerous because you can miss packets, drop packets. You're assuming whatever you're sending out is a lot like a message in a bottle. You really don't care if it gets there or not. You're just sending it out, and if somebody grabs it, they grab it. So the big thing here is this is used a lot in, well, lower level protocols and even embedded devices. Like think of like a weather thermometer. It may just be sitting there broadcasting out the weather via UDP on your wireless, but it doesn't really care if you're listening to the weather or not. It's just going to keep churning it out once a second. So let's dive in and take a look. As always, the first step is, you guessed it, imports. So we are going to, in traditional fashion, just copy and paste. We're going to use logging, multiprocessing, threading, socket, sys, and time. I'm not sure if we're going to use all those, but we're going to figure it out. And logging, we're going to go ahead and do a basic config. Now, the main premise here is we're going to create two processes, and we want to, well, run one process as a broadcaster and one process as a listener. So one of them is going to be speaking and the other one's going to be listening to that. But they could both speak if they wanted to. Remember, with UDP, there really are no rules. It's up to the user to define what's going on here. All right, the bulk of this program is going to be in this little section here, where we're going to actually build up a socket. Now notice I'm not saying a client or a server or anything like that. We're just going to make a socket. And this is going to be run on a process, and each process is going to treat this a little bit differently. So let's go and say def make underscore socket. I want the IP to be localhost port, and I'm just going to pick a port. You could be super fancy and follow the last video where you could actually determine if a port's in use. But I'm going to say port 2045 by default. And sender equals false. Now, sender is really what we're going to be working with here, because we want one of these to broadcast and one of them to listen to that broadcast. Think of it like a radio station and somebody listening to the radio. I'm going to go ahead and say proc equal multiprocessing. I want the current process name. That way we know what process is actually running this, because we're going to have two processes and each one of them is going to run this function, except for one of them is going to say sender false and one of them is going to say sender true. All right, let's get some screen real estate there. Say logging info. Go ahead and format that, and I want to say whatever the process is now starting. Let's go ahead and get a socket. So I'm going to say s equal socket dot socket. And I want to say the address family is iNet or IP version 4. And this is where you got to kind of pay attention a little bit here, because this is how we actually build a UDP socket. So I'm going to say socket dot, and instead of sock stream, I want sock dgram or datagram. Again, if we scroll all the way up here, it is a user datagram protocol, not a stream of data. So it's just a chunk of data that's flying out on the wire. So sock dgram. Now I'm going to go ahead and say, if we are the sender, logging.info, and I'm just putting this out here. You don't really have to have any of this for it to really function. I want to know what we're doing in advance. So I'm going to say F, and I want to know the process. Is starting to send. And let's go ahead and grab this. And we're going to say binding to port. So the main thing here is if we are the sender, we're just going to start sending. However, if we want to actually listen to that conversation, we need to now bind to that address. And depending on your OS and a whole bunch of other factors, you may have a bad time if you try to do this multiple times. We're going to cover that a little bit more in depth in future videos, but I just wanted to throw that out there in case somebody tries to do like 15 different clients on the same bind. There might be a different way you have to do it. Again, we'll cover it. And we're going to say, make an address out of the IP and port. Go ahead and bind. We're going to go ahead and bind to that address. Now, what bind does here is it really says, go out to the network card and listen on that port for UDP packets. Doesn't really matter what those packets are. I just want to listen to them. Now I'm going to say with our socket, we want while true. And this is why we're doing multiprocessing, because we're just going to do a blocking socket and we're just going to do an infinite loop. And I want to say if we are the sender, again, screen real estate is our buddy here. Get this. Sending, just so we can see what's going on under the hood. And I want to send to, and there's a whole bunch of different options, but for this one, we're just going to send to. You may get super excited and see send file. Yeah, UDP is really not the best protocol for doing that. You definitely can, but it's really not the best. TCP is a better option for sending files. We're going to say hello UDP, and that's really all we're going to send. And we're going to go ahead and send that on the IP and port. Now I'm going to say time.sleep, and we're going to go ahead and sleep for 1 second. Else we're going to say data and the address. And we're going to go ahead and receive from. And we covered this in the TCP video. Very, very simple. We're just going to say we want an upper limit to how much data we can actually receive. In this case, 1024 bytes. We're not even remotely sending that. We're just sending this right here. But you got to have that out there just to be safe. And then let's go ahead and say time.sleep. Actually, don't need time sleep. What was I thinking? There we go. Logging info, and I want the protocol from, you definitely could sleep if you wanted to, but it would probably not be good. From the address, there we go. And then we want to know what data we had here. All right, lots of typing. Any misspellings, Bard? Let's go ahead and run this, make sure we don't have any little gremlins. Cool, doesn't look like I really destroyed anything too much, but the main takeaway here is we're going to make a socket which is going to run in a process. It's going to be on the local host on the default port of 2045, and you can define the IP and port. And we're going to be able to determine if we're sending or listening, and we're doing that on IP version 4 using a UDP socket. And then from there, we're saying, if we are the sender, we're going to go ahead and send once a second hello UDP to that IP and port. However, if we're listening, we're going to go ahead and receive. And this is blocking, so it's going to sit there and block the entire time. And then once it's received some data and unblocks, it's going to say logging info, the process from address equals whatever the data was. Okay, my favorite part here. Let's see this in action. So we're going to take this make socket and put it into a process and then turn it into a broadcaster and then do the same thing on a listener. So let's go ahead and set up our main function here. And let's get some area of the screen so we can actually see me type all this out. And I want to say broad, if I could actually spell it, broadcaster. And I want the multiprocessing process. We've done this before. If you haven't watched the video, go back in the playlist and watch the multiprocessing videos I did. We're going to say the target is going to be that make socket function. Now we want some keyword args. It's not as cool as the word args. I like saying args, but anyways, we're going to say sender is going to be true. And then from here, we're going to say, yes, this is a daemon, which means it's going to shut down when our application shuts down. And let's go ahead and set the name to broadcaster. Ooh, that is very long. All right, so we're going to grab that, do the old copy and paste action here. That way we don't have to retype all that nonsense, and say listener. Go ahead and down here. Don't really need to set this because we have that default, but I'm going to set it anyways just to limit any confusion. So now we have a broadcaster and a listener. Notice how both of these are going to be on the local host on the same port. So both of them are using the same port. One's talking, one's listening. I'm going to go ahead and take our broadcaster. Let's go ahead and start that process. Now I'm going to take our listener. And let's go ahead and start that process. So now we've got multiple processes running. Now I want our main process or our main thread here to actually just kind of sit in the background. And then after 5 seconds, I want to shut this whole thing down. So I'm going to say time. Actually, let's go timer. Probably be vastly more helpful. I'm going to say threading, timer. And in 5 seconds, I want to do a sys.exit. And I want to say we are exiting normally. That way nobody panics. Well, let's just go ahead and start that. Now, assuming I typed everything correct, this will just work fine. So let's get some screen there and let's run this. Uh-oh, we had a boo-boo. Let's see what's going on here. In make socket. What is going on here? Run self, so file, blah, 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 line 40 in socket, send to address. Local variable address, a reference before assignment. Ooh. I wonder if anybody watching caught that while I was typing it. So what it's saying here is, scroll through this. On line 40, this guy right here, address reference before assignment. Interesting, it's up there, so easy fix. There we go. Go ahead and clear that. All right, now it's working. So you can see broadcaster's sending, the listener's listening, and the listener's getting that information, and then it shuts everything down after 5 seconds. So minus the little typo that I had up there, everything is working. The main concern here is that we're using UDP. You notice the broadcaster and the listener, actually I had those backwards, the broadcaster and the listener have no idea the other exists. The broadcaster is just going to send data out, doesn't even care if anybody's listening. And the listener is going to say, hey, is there anybody out there? If so, tell me, what am I listening for? And that's going to say, boop, this is the data. So UDP, I'm not a big fan of UDP. We're not going to really do a lot of elaborate deep diving. We're going to cover it a little bit more in depth later on, but I want you to understand what it is because it is the counterpart to TCP. Remember, TCP has that 3-way handshake and it guarantees a connection and it guarantees the data sent. Otherwise, you get a socket error of some kind. Where UDP, what we're working with in this video, just literally throws it out into the abyss. And if you want to listen to it, it's up to you to figure out how to get it. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all 3 of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and in this video, we're going to discuss blocking versus non-blocking sockets. I'm going to paste some documentation here. So blocking stops. Whenever you see the word blocking, think immediately like you're going to shut the door. So blocking will stop execution of your program, and then it will proceed once the function completes. Non-blocking, which is a little bit new to us, this is what we're going to cover in this video, runs in the background. And there's really one correct way of doing this, and that's to use select. This is completely new to us, and it looks horrible, so I wanted to explain it right up front. What we're going to do, we're going to hand it a list of readers, writers, and potential errors and give it a timeout. Very important you give it a timeout, otherwise it will actually block, which defeats the whole point of non-blocking. It in turn is going to give us a list of things to read, things to write, and errors. A little bit crazy the way this works, and to be brutally honest, this gets super complex, so we're not going to do it the ultra professional way. We're dialing it down and doing it the newbie friendly way. And spoiler alert, yes, there are whole frameworks on how to do non-blocking programming. We're not going to cover those just yet. We're still in newbie land. We will get there eventually. So if you want to go out and peek at this documentation, you can see it's kind of complex. So we're going to try and dial it down. The basics here is in Python, you use a socket set blocking 0 to make it non-blocking. That's the big takeaway here. But the moment you do this, bad things happen very quickly. And the author goes on to say, the correct way to do this is use select. And then they give you the template, which I just displayed. Let's dive in and take a look. As you might expect, the first step in any program is, well, imports. And I'm going to save just a microsecond of time by doing the old copy and paste. We're going to import logging, socket, and select. Now, you notice if I hover over select, it says, this module supports asynchronous I/O on multiple file descriptors. What does that really mean? So we're working with asynchronous programming. We've covered that a little bit in this series so far, and we're doing that on multiple file descriptors. Now, that really in plain English means we're going to do something on the same thread at the same time using a file descriptor. Now, a file descriptor, this is a little complex, but basically on Unix, everything's a file descriptor. It just means it's a hardware device of some kind. It gets more complex, but that's the dumbed down version of it. On Windows, only sockets are supported. Very, very, very key takeaway on this. So if you try to use the select with a file on Windows, you're going to have a bad time. All right. Now, also, while we're in import land, I want to do our main function because, well, it's pretty rudimentary. We've covered it like to the point of just being ridiculous. So I'm going to say main, and we're just going to flesh this out. I'm just going to put a pass in here. Just didn't want to skip any steps so people watching this don't go, hey, where did main come from? We're going to fill that out as we add in some code. So we're going to do two examples. The first example is going to be a blocking socket. And we've done this before, but I want to do it again just to illustrate what's happening here. So I'm going to say def create underscore blocking. We want a host and an IP. And then I'm going to, off the screen here, just grab something, copy and paste to speed this little section up. So we're going to say logging info, blocking, creating socket. Now let's go ahead and create that. We're going to say socket, and then we want a socket.address family of inet, which is our IP version 4. And we're going to go across the internet to my very slow website so we can see in real time just how blocking works, which means we need a TCP connection because we're going to be working with HTTP. So I want a sock stream, so we're on TCP land. If you skipped any of my videos, I highly recommend you rewind and watch them because we covered all of this so far. Now we're going to say blocking, and I want to say connecting. Anytime I say s dot, whatever we put is going to block, meaning this function call that we're going to do is going to hang our program up until it's complete, good or bad. So I'm not going to put a lot of try and finallys or any of that other error handling in there. We're just going to assume this code's going to work just for illustrative purposes. So we're going to try to, and I need a tuple here, connect that host IP. Now I want to know that this was connected. And once this is connected, I want to say sending. We're going to go ahead and say s.send. We want to send some bytes. /r/n. Now, the beautiful part about my web server being, well, rented and slow is that it's going to really show you just how painful blocking sockets can get. So we're going to say blocking, and I want to say waiting on response. And you're going to see when I run this that it's going to sit at waiting on response for a long time. And actually, I'm just going to shorten that. Just say waiting. Once the server responds, because it'll eventually time that socket out and spit back some kind of error message, it's going to say, here's some info about the error. I don't really care what it was. So I just want to know the length of this. So we're going to grab that. I'm going to say data equals, go all the way to the front. I want to format this, go all the way back here. So I just want to know how much data it actually sent us. From here, we're going to go ahead and close this. Now, close should happen very, very quickly, but again, we're blocking. So on older systems, especially like embedded systems, that may hang for just a few milliseconds, but it's still blocking. All right, now that we've got all of this, assuming I didn't mistype anything, let's go down here. And we're going to run this off my website, which of course is running on port 80. And let's get some screen real estate, see what this looks like in blocking mode. So creating, connecting, connected, sending, waiting, and it's just going to sit there for a while. This is the painful part of blocking sockets. Eventually it will time out the socket on the server and it's going to send back, yep, some sort of error message, which was 513 bytes, and then it's closing the socket down. But again, you see how it kind of stepped through. Some steps are faster than others. When we got to the waiting part, our socket is blocking for what, well, feels like an eternity in computing time because we're just literally not running. This means we're not running our script. Our script is just pretty much frozen in memory until the server responds back. This is really not cool, but this is blocking sockets 101. Now that we understand blocking sockets pretty much in depth, I'm going to make a different example. We're going to do the non-blocking socket. And this is going to be much more complex. And I'm going to just put a disclaimer right here. This is not what I would consider client ready or industry standard. This is just an example. So it's a very watered down example, and it's not a one size fits all solution. So if you're just looking for this for, hey, I'm going to copy and paste this into my production app, don't do that. This is just a demonstration. All right, now that we've got that disclaimer out there, I had somebody write me and say, hey, I took your code and pasted it into my app and the client complained because in the log it said this is a test. Well, shockingly, when you copy a test code. Anyways, so we're going to create a non-blocking. So let's rename that. And let's just switch this logging out to non-blocking. The first part of this code really is going to be look shockingly similar. So we've got our socket here. Now we're going to try to connect to the host. So I'm just going to say connecting. So far, we're not non-blocking, meaning we are still blocking. Let's go ahead and get the return value of, and I want to go with s.connectEx because I don't really care. I want to just get the return value. I'm going to say host and the port. And this is going to block right here. So this is a little misleading. I just want a very big disclaimer, block. That way nobody on the internet yells at me, although I get yelled at quite a bit. We're going to say if the return value is not 0, something bad happened. And I want to say failed to connect. And then we're just going to get right out of here. However, if we've gotten to this point, we're going to say connected. And this is where the code's going to get really, really interesting. So I want to take that socket and I want to set locking, where are you? There you are, to false. When we do that, something both magical and horrific happens. Your code will start having a lot of errors if you try working with it in a blocking fashion, and they will be like blocking IO errors and things that make absolutely no sense. So we have to do this a little bit different. We're going to work with the select command, and let me scroll way up here. It is horrible to look at. So basically, it's going to give us 3 lists: things we can read, things we can write, and errors. But the select is going to say, we want to give this potential readers, things we could read from, potential writers, things we could write to, potential errors, and a timeout. Very important we give it a timeout. If we do not, this will work in pretty much a blocking fashion. All right, so back down here, we are going to say inputs equals, and we want to make a list. We're just going to put that socket in there. Outputs, same thing. Now, this is where things get a little bit tricky. Because we're working with HTTP, we have to send the server information first and then read back a response. So I'm going to say while we have inputs, meaning while we're still expecting some sort of response. Let's go ahead and grab this. And I'm going to just put the infamous waiting. Now you may be curious why I'm putting waiting in here, because I want you to see that this is not blocking. You're going to see that waiting repeated over and over and over to demonstrate we are in a loop. Now we're going to use that select statement. So we want a readable, a writeable. Is that even a word? That's not a word. There we go. And I'm actually just going to call this errors. I was going to write exceptional, but we'll be here all day watching me fumble around on the keyboard. Then I'm going to say select.select, and we want our inputs. That's just our list of sockets. Our outputs, again, list of sockets, and our inputs. Now you may be scratching your head going, whoa, what are you doing here? So remember, things we can read from, things we can write to, things we're expecting errors on. Again, we're expecting errors on our input, but not our output. Now we have to give this a timeout. I'm going to say 0.5 or half a second. If we skip that part, this will block. So we need to put a timeout in there. And select is going to return 3 iterable items: readable, writable, and errors. And I can actually, you know what, I'm just going to copy and paste it because it's going to bug me. It's different than my notes. Readable, writable, and exceptional. Did I even say that right? Exceptional. I got to work on my accent. Anyways, let's just go ahead and move forward. What this does, though, is every timeout, in this case 0.5 seconds, it's going to poll the underlying operating system and say, hey, I'm looking for anything that has an input, anything that has an output, or anything that has an error. And if you don't have anything, I'm just going to break right out of this. And I shouldn't say break, it's going to reiterate the loop. I'm going to say for s in writable. I'm going to go ahead and pass. And then for s in readable. I'm going to go ahead and pass. And then for s in exceptional. Again, we're going to go ahead and pass. And this is the basic program structure here. So first things first, once this socket has connected to the server, it should be writable. So we want to write out to the server. Then we're going to remove that socket so we no longer have something that's writable. And it's still going to be in our inputs list or our readables. And it's going to want to know, hey, tell me, server, when you send me data. And then once it's readable, we're going to read that data in. And if we have an error, we just want to be able to, well, basically jump right out of this thing. All right, so let's start with our write. And I'm going to go back up here, grab this. Just want to let the user know, hey, we are sending some information. And I want to say send. And again, this is going to be bytes, and I'm going to send the exact same data. /r/n. I'm going to do it a little bit different than the previous one. So I want to say, we have now sent this information. Just so we can see the length of bytes which we have now sent. Now I want to take our outputs and I want to remove that. There's a reason for this, because every time this loops, we don't want to tell it, hey, we have a socket we want to output on, or this is going to fire off every single time. So we want to remove that out of there. Finally, let's get rid of that pass because we're not passing. Now we're going to assume that this loops again, and now it's going to say, okay, we gave it an input with a socket in it still, and it is now readable, meaning the server has now sent a response back. So we want to read that response back from the server. And this is all happening asynchronously, so it gets a little bit confusing. So we're going to say reading, I'm going to say data equal s.recv for receive. Now in our receive, we want to say we want no more than 1024 bytes, because yes, the server could just slam us with thousands and thousands of bytes, and we don't want that. And then we're going to say, we want to know what we got. So we want to know the length of that data. And then I want to close the socket down. And then I want to take our inputs and actually remove that. Because again, when this loops back through, it's going to do that select again, and I don't want that same socket going back through this select, because then it's going to just keep continually reading it. Once we get that response back from the server, I am done with this and I don't want to mess with it. Now we're going to say we are done, and we're going to break out. I always like that. Break out kind of reminds me of like 1980s, 1990s breakdancing, but we're going to break out. And if we had some sort of boo-boo, as I like to call it, we want to notify the user, hey, there was an error, something bad happened, and we're just going to, you guessed it, remove these things immediately. And if you want to be super conscientious, you can actually break as well. Now, you notice one thing, this is much, much longer than our blocking. Our non-blocking is way more complex. We are doing a loop within a loop within a loop, and this gets nuts. So let's go ahead and grab this and see this in action. Go all the way down here, comment this out, and assuming I have not mistyped anything, which I'm notorious for mistyping, you'll see non-blocking in action, and then we'll jump back in and re-explain everything. So, of course, what did I mess up here? Line 45, create non-blocking, connected blocking. Port not defined. What do you mean port's not defined? I think every programmer has probably, yes, see, I said host IP. I think every programmer has looked at their output window and went, what do you mean not defined? All right, so we fixed that silly little error. Let's clear that out. And fingers crossed. Uh-oh. What did we screw up here? So you could see it went very fast until it got to this. Line 63, create non-blocking logging, len data. Object of type int has no len. So line 63, and some real-time troubleshooting here. Yes. Okay, so let's go ahead and silly me. So send is not going to send us any byte array. It's just going to send us an integer. So I was kind of silly that I did length there. Now let's try this. Mistakes abound. There we go. Now you can see that beautiful loop in action. So what's going on is connecting, connected, waiting, and it sent 7 bytes. And now we're waiting for that server to time that connection out. Finally, we had some information on the line we could read from it, and it sent 513 bytes back, closing. And you notice our loop stopped, and then our script stopped as well. So what's going on here? Let's take this thing from the top. So just got rid of a little too much. Let's see if I can get that back. Ah, there we go. All right, so we go into create non-blocking. We want an IP version 4 TCP socket. We get that. We say connect EX, which basically means I don't care what you do. Just give me back a status code of what you've done. If it's anything other than 0, I want to say we could not connect, and let's just jump right out of here. From there, I set the socket to blocking false, meaning we want this to be asynchronous from this point forward. If you skip that step, this code's going to be kind of funky, but it may actually still work. Now, if you use this and treat it like a blocking socket, like you're used to, you're going to get all sorts of blocking IO errors, and you're not going to be able to figure out what's going on. And basically, that's Python's way of telling you you need to pull that object in the background, and that's exactly what select does. Every time we loop through this, select is saying, hey, here's a list of things we could possibly get input from. Here's a list of things we possibly may want to write to. And here's a list of things that may give us some sort of headache in the future. Again, I just use the inputs we're going to read from. And you know what? I want this to time out in half a second. And you can tweak this to whatever you want. Our first iteration, it's going to say for S in writable, meaning, you know, whatever we've got back here. We should just have one writable socket. So we're going to have blank writable socket blank. So only this is going to run, assuming nothing broke. And that's when we send the data out to the server. Then on the second and third and fourth, and it's going to keep polling, waiting for that server to turn a response. Once it responds, you'll have a socket, nothing, and hopefully nothing. So then readable runs. And you notice how I did a for, because these are iterable. So I just wanted to just kind of future-proof this code. Doesn't matter how many readables. And then we're going to go ahead and receive that information, close the socket, remove it. Once we do a select with nothing, 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 guess what? It's done looping, and we have now breaking out of here. And of course, if we have some sort of error, we're going to say, uh-oh, we want to remove everything and break out. Now, there are some gotchas here. And I have admittedly overly simplified this to the point of some of the things that I've said probably are either vastly inaccurate or make zero sense, because this is actually pretty complex under the hood. So I would highly encourage you to go read the documentation. We are going to do more complex examples in the future, and we may, and well, more than likely, touch on some high-performance TCP frameworks that are out there. But I wanted to really touch this first because it is so complex. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and in this video, we're going to dive even deeper into Python 3, and we're going to look at what it takes to make a TCP echo server. So what is an echo server? Well, it's a server that handles multiple clients at the same time. So we're obviously doing non-blocking sockets. We're going to push this off into a separate process, and it's going to echo back the data the client sends it. This is very, very helpful for network programming if you're doing any sort of troubleshooting. Let's dive in and take a look. Step one, of course, is imports. And I'm not going to waste a bunch of time because this video is going to use things that we've already covered in this series. So if what I'm about to copy and paste on the screen makes no sense, well, you might want to rewind and watch some of the videos. So we're going to use logging, multiprocessing, sockets, and of course select because we're using non-blocking sockets, or more appropriately, we're going to be using asynchronous code. Now this all happens under the hood, so we don't have to worry about async calls. Select does all the work for us. And of course, we're going to set up our logging basic config. we want to basically grab everything. So we're going to use logging.debug. And now for the heart of the tutorial, we're going to actually make the function that defines our server. And this is going to run in a separate process, but of course, the way Python handles multiprocessing, it's simply a function. So we're going to say def chat server, and we want an IP and a port. From here, it's pretty standard what we've done before. We are going to deviate a little bit, and I'll point those out. So we're going to say server equals, and we want socket dot socket, and we want the socket dot address family IPv4. Feel free to switch that to IPv6 if you really need it. And we are going to be using TCP, so we want a socket stream. So we need to say socket dot sock stream. In case you're wondering, yes, you can do this in UDP, but of course you don't need an actual full-blown server with multiple connections because of the way UDP works. There is no such thing as a connection. I'm going to, just for the sake of time here, we're going to say logging binding to IP and port, and then from here, we're going to actually bind. So I'm going to say server dot bind, and we want to go ahead and make a tuple. We want the IP and the port. Of course, if that is already in use, we're going to crash our program at this point simply because, well, that's the nature of what's going to happen. You could definitely wrap that in a try finally if you wanted to. Now we want to take this server and set it to non-blocking. So I'm going to say server, and we want to set blocking to false. That means from this point forward, we are not going to block the execution of this application. Let's go ahead and say server.listen. And I want a maximum of 100 connections here. Logging.info. Actually, what am I doing here? Let's just go ahead and paste it. Why not? We're going to say listening on whatever the IP and the port is. Now, from here, we're going to start working with select. So I want a list of sockets we can read from. So I'm going to say readers, and we want a list, not a dictionary. We're going to add our server to that list of sockets. Because remember, select doesn't care what we add in there. It just wants to know, what are we reading from? What are we writing to? What are we getting errors at? So let's go ahead and say, while true, we're just going to loop forever. Now we want readable, writable. Did I spell that? I did. Somebody out there needs to really correct me on my spelling. Errored. That's going to be the select.select. And if you watched the previous video, basically we need to give it a list of things we can read from. So we're going to say readers. A list of things we can write to, which I don't really want to pull for writing, so I'm just going to give it a blank list. And a list of things that could possibly raise errors, which I'm not going to involve select in that little process, so I'm just going to give it another blank list. There's probably a more elegant way of doing that, but this just works. From here, we're going to say for s in readable. In case you're wondering where readable is coming from, it's right here. So what's going to happen is every single time this loops, select is going to go in and say, hey, do you got something for me? Be sure, of course, to put a timeout here. Otherwise, you're going to have a very bad time. So we're going to say 0.5. And let's go ahead and try this. So I'm going to say try. We want a try exempt finally. So for every single socket in readable, we're going to try something. And then finally is going to pass. And then let's go ahead and flesh this out first. So I want exception as EX. And then we just want to, and I'm going to just grab this. I'm going to put out a warning. And I just want to see those args in our log. Finally, I don't really care, so I'm just going to pass. Now try, this is going to be the heart of our server. I want to say if s equals the actual server, meaning the server socket, then we want to do something with that. For the moment, I'm just going to say pass, and then we're going to say else, and then I'm going to pass on that as well. just so you can see the structure here. So every single time select fires off, it's going to give us a list of readables. If we have a socket in there that equals our server, then we want to handle that. So really all the server is going to do is accept incoming connections. So I'm going to say client, comma, address equal, and I want to say s.accept. We could have said server.accept, but it really doesn't matter. We've already got the object as s. And then I'm going to set that client to non-blocking as well. We're going to say set blocking false. We're going to append that to our list of readers. So we're just going to take this client and put it right up here with this list. So we're going to say like client, 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 client as we get extra clients, and then we're going to have to remove those as they drop out. So let's go ahead and take our client, send that to our list. And now I want to say logging.info. I want to know that this guy actually connected to us here. And let's go ahead and get the address. There we go. So it's really that simple. Really all our server does is it just listens for incoming connections. Once it gets a connection request, we go ahead and accept it, add it into our list, and then we will handle that later. So when we get to else, that's when we have to actually handle that. That's one of the clients saying, hey, I want to talk to you. Let me fix this little guy. We're going to have a bad time. All right, so once we get here, I'm going to say data equal s.recv for receive. We want a maximum of 1024. Now we need to determine if the data is blank. So I'm going to say if we have data, then do something. Else, that means we have no data and that socket is now basically closed. So I'm going to say, just for the moment, pass. Let's jump up here and assume we have data. And I want to know what we're actually echoing back to the client. So I'm going to say logging.info. And I'm just going to print out echo. And then whatever data we're echoing back. That way I can see it in the log. I'm going to grab this. And let's go ahead and say s dot. And we want to send them the same information they just sent us. This is the whole point of an echo server. It just literally echoes the data back. Pretty useful. That way you can see if the data you're sending gets changed in transit. I've actually had that happen before when I was writing a network program. Really, really infuriating. So if there's no data, then we want to remove this. So I'm going to say remove. And let's go ahead and just say what we're removing here. Go ahead and close that socket down, or at least try to. And then I want to remove it from our list. So I'm going to say readers dot remove, and we want to remove that object. Pretty simple, pretty easy to understand. I'm going to give this a good run, make sure we don't have any gremlins popping up in our code, and we are good to go. Now that we've fleshed out the server, I want to do our main function. So I'm just going to collapse that code. Let's go ahead and fill this in. I want our main function to do something a little bit more than just run a server here. So I'm going to say SVR equals multiprocessing. So if you skip that video, I highly encourage you to go out and watch it. But basically, we're going to make a whole new process and shove this server out into that process. I'm going to say, whoops, target equals, and we want our chat server function. I'm going to go ahead and give it some args. So I'm going to say args equals. Give it a list of arguments. We need the IP and the port. So the IP is just going to be our local host. And the port, again, this is going to be very dependent on your system and what you got running, but I'm going to put this on 2067. I want this to be a daemon. That way, when our application shuts down, it kills that process along with it. And let's go ahead and give this a name of server. Name is not really mandatory, but it just helps in logging land. All right, so Now that we've got the server, I want to be able to do something with it. I don't want to just fire it off immediately because we are building an example application. I want to have the end user have the ability or the control to start and stop that server. So I want to say while true, and we're just going to lock up this main thread here with user commands. So command equals, and I want to get the input from the user. I'm going to say enter a command, start or stop. Pretty self-explanatory what's that going to do to our program here. And we want to say if the command, and you could do some special things like, make sure it's lowercase or uppercase or, there's no padding or anything like that. But I'm just going to keep it super simple. I want to say starting the server so we get some feedback on the screen, and I'm going to say SVR. We're going to go ahead and start that. That's going to kick that process off. However, if the command is stop, then we want to actually kill that running process. Now, there's a lot of little gremlins that we could introduce here, but I'm going to keep it super simple. I'm going to say stopping the server. And we're going to say svr.terminate. We're not going to do it very friendly. We're just going to say, hey, stop running. We're going to wait for that to join back to our current context of execution. And then we're going to free up those resources by closing that process down altogether. And then I'm going to say server stopped. Once we've gotten to this point, you could actually break this out and then say, hey, we're now done. All right, let's give this a run. Make sure it's going to give us a command prompt. Okay, let's see this in action here. So I'm going to start this, and we probably have a few bugs we'll have to work out. And we are now listening on localhost 2067. Let's go ahead and fire up a command line. I want to open up Telnet session. And if you're on Windows, I'm sorry, you're going to have to install probably PuTTY or Telnet or something like that, because I don't think it comes actually built into the OS. Everything else, you should just be able to do this. So we're going to say telnet. And this is on port 2067, and my spelling has probably screwed something up, and uh-oh, of course we have a problem. So connection closed by foreign host. That usually is not a good sign when you're connecting to a server. And we got a warning, name client is not defined. Name client's not defined. Okay, so what's going on here is we have what I like to refer to as a boo-boo. I have client.address. Well, remember, socket accept returns two things, not one. And we're basically saying we have a class named client that has a property named address. Nope, that's not the case. It's client, comma, address. We've also introduced another problem. So let's kill this thing and rerun it. And let's try to start this. See, now I'm frustrated and I can't type. Uh-oh, address already in use. When you see this, that means something else is bound to that address. Now, wait a minute, we just did it and it just ran. So what's bound to that address, of course, is our program. And you can see out in my system monitor, Python 3.8, of course, is consuming 5.2 megs. And normally I don't advise doing this. You can't see what it is, but you can see there is the full path to our script, Python 3-60.py. So that's what's got that address in use, meaning that is now still running in memory. We never stopped that. So let's go ahead and kill that. And you can see it is now killed. That should have freed everything up. Let's go ahead and clear that out. Fingers crossed we don't have any other gremlins here. Let's go ahead and rerun, and let's go ahead and start this. Now we're able to rebind listening on localhost 2067, and let's go ahead and reconnect here. All right, now we've got a solid connection. Our remote client is 127001 on port 52444, and we can just simply say test. and it's going to echo it back. For example, I can say cat, and it will send cat back, dog, etc., and so on and so on. So let me open up another command line, and let's go ahead and say telnet. And I want to say 127.00.1 on port 2067. And you can see we have a different connection, and let me move these out of the way here. And this one is on port 52468. And this thing works as expected. Now we can go ahead and close one client. You can see it has removed that socket appropriately, and this one works. So the other connections are not impacted. Now we can take this and have the user call stop. And it does what we expect it to do. Stopping the server, stopped, application finished. We've now exited that whole application loop. I go back out to my system monitor. There is no hung process out there. And if we flip back to our command line, we can see connection closed by foreign host because the server slammed that connection closed and deleted the socket. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching. Welcome back, everyone. This is Brian, and in this video, we're going to talk about date time. Dates and times in other languages are, well, a pain, but Python makes it ridiculously simple. This video, we're going to talk about dates, times, deltas, and formats. Let's dive in and take a look. The first step, of course, is imports, everybody's favorite. So we're going to say from, and we want the date time. We're going to import date time and time delta. So what are these things? Well, datetime is the module and datetime is the class we're going to work with. And time delta allows us to take a different time, or I should say a time in the past or the future, and add or subtract numbers to it. So you could say, hey, I want to know the date 30 days from now or 5 weeks from now. And we want to be able to format these things. So I'm going to say from time import. And we want to string format time. What that's going to allow us to do is say something like, today is December 2017, but put it in a nice, pretty string format. All right, to begin, let's go ahead and make a main function here. And we're going to talk about now. Meaning right now. We're going to do this literally right now. What is now exactly? Well, it is a representation of, well, the current date and time. So I'm going to say date time dot now. Now you should understand what's going on under the hood when you do this. You're saying go out to the operating system and say, operating system, what date time do you believe it to be? However, that might not always be the actual date time. So I'm going to say datetime dot UTC now. Special note here, if the machine is on a UTC time zone, then there'll be absolutely no difference. So which one is right for you? Well, it depends on which one you want. Personally, I tend to use the UTC. Let's go ahead and just print some stuff out. I'm just going to, through the magic of copy and paste here, we're going to say print out now, print out UTC, and I want that offset. So let's go ahead and print. You can see there's absolutely no offset here. So these are exactly the same. Now, they're not actually exactly. You notice these last two little numbers here. That is actually the difference in time between this print and that print. That is your computer running. That is an incredibly small amount of time. It is called a microsecond. Let's talk about time. Time is split into logical units, and don't worry, you're not going to sit here and watch me type for hours on end. But it is split into logical units, meaning you have hours, minutes, seconds, and microseconds. If we run this, everything just seems to work. It is the 16th hour, 17th minute, 27th second, and there is our microseconds. And of course, milliseconds being up here. Now, you may be wondering, what's the difference between now and UTC? Again, because there is no offset, they should be identical. This is a very simple, easy way of grabbing this. There are a lot of tutorials out there that show you some long, exhaustive ways of doing it, but why bother? Just grab the datetime now or the datetime UTC now, and then grab the hour, minute, second, or microsecond, depending on what you need. Time waits for no one, and time is precious, so I don't want to waste too much of your time here, which is why I'm doing a lot of copying and pasting. Dates are, well, just as simple. I'm just going to do the old copy and paste for dates. Year is now year, month now month, day is now day. Now, you may notice sometimes if you're typing away here, it may or may not, depending on what you're working with. Let me find one here. Hour, there we go. So IntelliSense is picking up two of these. It's saying hour and hour. I'm going to just run this and let's see what happens here. Just wanted to put a quick note in there that sometimes IntelliSense will betray us. Datetime object has no attribute of hour. If you ever get that, check your case sensitivity. For example, ta-da! But of course, that's not the right thing. Major takeaway from that is case sensitivity does matter. Grabbing the hour, minute, second, microsecond, year, month, and day is ridiculously simple. There's no sense in wasting a ton of time trying to figure it out. All right, this is where we slow down a little bit here. We're going to talk about deltas. A delta is a difference between two numbers. So what we want to do is do some date computations here. For example, let's find what the date is going to be 30 days from now, or a month from now, I should say. This is where Python's a little bit lacking. There are other ways of doing this. I just wanted to show this to you really, really quick. So I'm going to say next month. And we're going to say now plus, and we want time delta. Now you're inclined to go, oh, this must be easy. I'm going to say month. And then, oh, doesn't work. And then you go, oh, I know the problem. This is uppercase. You go, still doesn't work. What the heck? Maybe it's months and it still doesn't work. This is one of the shortcomings of the time delta, is that it really doesn't have that concept. You have to do it in simpler terms. So I'm going to say days. And let's go ahead and do it 30 days out and see what this looks like here. Now suddenly I get next month's date, which will be January 16th. So it's a shortcoming, but it's really not that big of a deal. There are other ways of doing it, but I don't want to get super, super complex here. So I'm going to say last week. Now I'm going to say time delta, and let's say weeks. And we are going to -1. So what this does is it takes our current date time and reduces it by whatever number. So last week was 12/10. It becomes ridiculously simple from this point. I'm just going to, for the sake of brevity, copy and paste the rest out. I think you're smart enough if you're watching this series to figure out what's going on here. So 5 hours from now would be time delta hours 5. 45 seconds would, of course, be seconds 45, 200 milliseconds, 10 microseconds, and so on. It is just ridiculously simple to work with this. The major caveat being you're going to start stumbling into little inconsistencies like I displayed with the month. Now, sometimes you need to work with a string representation of a date, and that's where ISO strings really come into play. So I'm going to say D equal, and I want the datetime dot from ISO format. And you notice how you've got a whole lot of things you can say from calendar, from ordinal, from timestamp, but we're going to do ISO format. Now, there is a special format you have to follow. For example, I'm going to say 2020-12-16. You can very easily go out and Google ISO format and find out what it is. We're going to go ahead and say print. Ta-da! Notice how there's no time because we didn't include the time in the format. So it is at 00000, basically midnight. All right, that is super simple to work with, but there's one little gotcha you should really understand. So I'm gonna say m equals, and I wanna say date time. We're gonna make this thing crash. And I'm gonna say from ISO format, and this is where trusting your end users could be a very bad idea. So let's say 2026 dash, I'm just gonna make up some gibberish here. I don't really care. We're intentionally trying to make this thing break. This looks like it could potentially maybe be some kind of date time. And nope. Value error. So it crashed our little program here. So you gotta just not trust your users. I'm sorry, it's really what it boils down to. So we're gonna say try. Let's do this. Get some screen real estate there. Bang, and there we go. Exception as EX. And let's just go ahead and print out the args. That way we can see we had an invalid ISO format and it gives us the actual string representation of that. So in case you're kind of curious, yes, you can actually get the ISO format from our now object here. So I'm gonna say print. We'll say ISO. And let's say now dot ISO format. And let's print that out. So this is the correct ISO format, and if we had put that in there correctly, it would have converted it. However, we just entered gibberish, so it crashed our little program. One of the more challenging things in programming is, well, formatting dates and times, and every operating system seems to do it a little bit differently, and every programming language does it a little bit differently. So I put a link out here. W3 Schools, big shout out to them. I'm not affiliated with them by any way, shape, or form, but they have this really, really great chart, and you can actually click this try it button, and it shows you exactly what's going to happen. So really what we're doing is a string representation of what we want the date time to be. And this seems a little bit confusing until you start wrapping your head around what's going on. So for example, a percent sign means we're going to format, and then we have some letter or numerical value depending on what you want. Python really doesn't have numerical values in there, but other languages and frameworks do. So we have percent lowercase. Whenever you see lower, think short version. When you see upper, think full version. However, they don't always line up. So for example, uppercase H is hour. And then this right here is hour. So what is the difference here? One is in 24-hour format, one is in 12-hour format. And it's just some of these little gotchas. You got to kind of figure out what you need in advance. And that's where a chart like this comes really super handy. All right, another really good example would be like capital A, weekday full version, lowercase w, weekday as a number. So you can do a lowercase, an uppercase, or a W. Why W? Why not? It's just how they designed it. So let's just dive in here and take a look. I'm gonna say print. And let's go ahead and format this out. And we're gonna say, actually, no, I don't want to format that out. Go ahead and say now dot string format time. And this is where those special codes would come in. So I'm going to say we want to format something. So the percent sign. And let's do a Y, which represents the year. So it's 2020. However, that's kind of just the number 20. It doesn't really represent how horrible 2020's been. So let's just uppercase that bad boy. And there it is, 2020. You kind of get the point. So I'm going to do a little bit of copy and pasting just to speed that up just a microsecond here. So for example, %D, D, %B, see what those do. And you can find out basically off that chart very quickly how you want to format that. Now, you may be asking yourself, there's got to be a way to do this a little bit more complex than this. I mean, come on, this seems overly simple. Yes, this can make your life super, super simple. For example, let's say we want to do something like this. Today is, and let's go ahead and say %B, and then lowercase d. Today is December 17th. I hope you enjoyed this video. You can find the source code out on github.com. If you need additional help, myself and thousands of other developers are hanging out in the Void Realms Facebook group. This is a large group with lots of developers, and we talk about everything technology related, not just the technology that you just watched. And if you want official training, I do develop courses out on udemy.com. This is official classroom style training. If you go out there and the course you're looking for is just simply not there, drop me a note. I'm either working on it or I will actually develop it. I will put a link down below for all three of those. And as always, help me help you. Smash that like and subscribe button. The more popular these videos become, the more I'll create and publish out on YouTube. Thank you for watching.